Hello there, and welcome to SQL Server Overview Training. My name is Graciano Frigo. I am a SQL Server DBA in IBM Brazil, and I hope you enjoy the content. The overall goal for this course is to provide an overview of the Microsoft SQL Server product from a production DBA perspective, so the focus today will be on the physical database administration. Here's a summary of the content that will be covered. We will start with architecture, where we'll show you some interesting components on SQL Server internal structure, as well as some key concepts that a DBA should be aware of. Then, a brief about security, some examples on SQL Server health check, and on the database structures module, we will look into the data and transaction log files, auto-growth settings, and more. Then, the backup and restore, that is one of the most important ones, and to finish, SQL Server agent, and a briefing on high availability solutions and performance basics. I have been working as a SQL Server DBA since 2012 in IBM, and prior to that, I have been on other technical leadership positions also in the mainframe area. So who is this course for? Since it is a SQL Server introduction material, the intention is not to go deep in any of the topic, but instead to provide a more summarized content on multiple aspects of the database administration. Then, it is recommended to professionals without experience in SQL Server or SQL Server DBAs that are starting their career. Or maybe, if you are a professional from another technologies such as Oracle and DB2, it might work for you as well. Module 1. SQL Server Architecture. So, if you are new to SQL Server, you might be asking, what is exactly SQL Server and what it does? Microsoft SQL Server is an RDBMS, or Relational Database Management System. It's available in the market just like competitors such as IBM DB2, Oracle, and others. And these are the main purposes of a database system. Data storage, meaning that SQL Server will be capable of storing large amounts of critical data on tables. Security, data protection is always a priority, and data must be accessed on tables, so security is always a concern. The backup ability, one of the core foundations on any database system. Performance, data not only should be accessible, but it should be done also in a very fast manner. And scalability, which is the capacity the software has to adapt itself to new workloads and absorb new features and components. Now, imagine you have a business, maybe a small retail store. Your application uses .NET or Java languages and require access to data that are on tables to perform basic operations. This is where SQL Server comes in. In this scenario, you will need a Windows server to host a SQL Server Instance, which is a copy of the SQL Server software, which will finally contain the databases where the tables are. This is a very simple example without any complexity, but it's just to give you an idea of how SQL Server works. Now, on this scenario, it adds a little bit of complexity to the scheme. Here, we have a high availability solution such as failover clustering on two nodes that are two different servers, where we may also have other solutions such as log shipping, database mirroring, or replication. Again, it is just to provide you an overview of the product capabilities, and this is just an example. There are many others possibilities. Microsoft SQL Server uses the Transact SQL as the primary language, which is a variation of the original structured query language created by IBM. While this course will not cover querying techniques, it is good at least to be aware of the major aspects of T-SQL. The DML represents data manipulation language composed by select, insert, delete, and update statements. Then we have the data definition language for creating, altering, or removing objects. The data control language used to grant or deny permissions to logins and users. And finally, transaction control language, which are the famous commit and rollback statements that controls the results of a transaction. Then, these are some examples of the main objects in a SQL Server instance. We have systems and user tables, systems and user databases, logins, roles, server or database level, schemas, and store procedures, view, trigger, and indexes. These are some of the most important tools used by the SQL Server DBA on a daily basis. So we have the SQL Server Management Studio, SQL Server Configuration Manager, the Event Viewer, Remote Desktop Connection, Performance Monitor, and the Windows PowerShell. These are just some examples. There are more tools depending on the industry you are working on or the type of your company. For example, you may have third-party softwares. On this slide, I wanted to show some important links that a DBA should be aware of. And I strongly recommend you to use these links after the end of the course to look for deeper contents. From white papers to video trainings, it is important for the DBA to know where to consult for correct information. The books online has a lot of useful documentation. TechNet forums, you have real-world problems where you can learn something from or even request help from other DBAs around the world. And there are many others such as SQL Server Customer Advisory Team Blogs, SQLskills.com, SQLServerCentral.com, Brent Ozer, Redgates, just to mention some. SQL Server Query Lifecycle Simplified. From this slide on, we will look into some of the internal aspects of SQL Server. If you have never seen this before, it might be confusing at first, due to the amount of terminology or concepts. So what I recommend is, after watching the other modules and practicing them, return to this part, as it will be much easier to understand. Let's take a look now at the basic life cycle of a query in SQL Server. Breaking Bad fans will certainly recognize this guy here. He will represent our end user. So this user has access to a device that could be a computer or smartphone and browse an online store for tablets and apply a filter. In this case, he wants the lowest price first. And then the result is displayed back to user, and he can apply the decision to buy or not the product. This is a very simple example, and now we're going to see what actually happens behind the scenes inside the SQL Server structure. So this is the SQL Server query lifecycle from an internal SQL Server perspective. Here we have our end user application, which will send a select statement to browse data. The command then will be encapsulated in some sort of package and will traverse in some layers until it reaches the SQL Server. It reaches the operating system, in this case the Windows Server, passes through the network firewall and the SQL Server network interface using TCP/IP. So the command finally reaches SQL Server. Before that, it uses TDS, which is Table Data Stream, a protocol that interacts with database server. So once it has reached the SQL Server, it goes to the command parser. The command parser will make sure there are no errors in the code, such as an additional comma or a missing object, and it will check if this object already exists, like a table or index. Once it finishes this, it comes the access method, which is a collection of code responsible for data retrieval. The access method will check for an existing query plan, and to do this, it has to go to the memory using the buffer manager that contains the buffer pool, and finally reaches the plan cache. If it finds an existing plan, that is, if this query is known to SQL Server because it was executed before, it will send it back to the query optimizer so the plan can be used. If it doesn't exist, the query optimizer will have to generate a new one based on statistics and other factors. So once a plan is generated for the query, comes the query executor, which name already says what it does. After this, the query executor will go again to the access method so that the required data pages can be read from memory because they are in the data cache. So they are retrieved from disk into memory. Or if they are already in memory, they are just read. And then the information is sent back to user using the same way it did before. There are two main engines in this whole operations. We're going to take a look at those now. So the command parser, query optimizer, and executor, these are part of the relational engine. And these other in green, they are part of the storage engine. The next slides, we're going to see some more details about them. So the relational engine is composed by the command parser, query optimizer, and executor. The command parser, as I said before, validates the syntax on the T-SQL being passed, meaning that if a query has any error, SQL Server will abort the whole transaction and will not move forward. The query optimizer plays an important role. It has the duty to generate an efficient query plan based on its cost, which may vary according to what information is available for processing, such as recently updated statistics. And the query executor, which is the name already says what it does, is responsible for processing the query in the CPU itself. So this image shows an example of a graphical representation of a query plan generated by the query optimizer. In summary, these are logical operations. And the storage engine is composed by the access methods, the buffer, and transaction manager. The access method is a collection of code for data retrieval, as I said before, and the query lifecycle. The buffer manager contains the buffer pool, which is the main memory consumer, and also the data and plan caches. And the transaction manager governs the log and lock manager. And these are, in summary, physical operations. Now, you may be asking why we did not use the log and lock manager in the query lifecycle. That was because the query was a simple select statement, so there was no data change at all. Next, we are going to view the definition of another key elements on SQL Server internal: data pages, write-ahead logging, checkpoint, and the lazy writer. The data pages are the smallest unit where data is stored in SQL Server. Every data page has a fixed size of 8 KB. So SQL Server maps data pages through extents, which are a collection of 8 contiguous data pages. An extent can be mixed or uniform, depending if it belongs to more than one object, and a collection of certain number of extents form an allocation bitmap, such as GAM, which is Global Allocation Map. And this image shows the body of a data page, where actual rows are kept, as well as some metadata like page header information. The write-ahead logging is a very interesting mechanism. It will ensure that all changes to the data pages has an associated record about that change in the transaction log before writing the changed data from memory to disk. This method, it guarantees the durability property of the transactions, which is the ability to undo or roll back or roll forward any changes for the transactions if necessary. So if write-ahead logging didn't exist, SQL Server wouldn't be a reliable database platform. And this is another reason why the transaction log is so important, and we will talk more about it in Module 4. The checkpoint is a data synchronization mechanism. In SQL Server, every data page change is done in memory, not directly in disk, where the physical database files are. So SQL Server marks the changed data pages as dirty and flushes them out to disk when the checkpoint occurs, so the information is synchronized with the log in physical files. The checkpoint happens every 1 minute by default, or it can be done manually by simply writing the checkpoint command. Additionally, it can occur in other circumstances, such as during log backups or during the simple recovery models, which we will see in modules 4 and 5. The lazy writer plays an essential role and is another mechanism that shows how physical memory is essential to SQL Server operations. It will use the last recently used algorithm to determine when a data page was last accessed in memory. And depending on the result, it can decide to flush the page to disk to release free space in the buffer pool, or if the page was not accessed during that certain period, it keeps it in memory because the page can be frequently used by another queries. Now let's take a look at the transaction asset properties. The asset properties are essential to be known by any DBAs. They represent key concepts around the transactions. Let's review each one now. The first one is atomicity. This property indicates that a transaction must be able to fully complete its operations to be able to succeed. Imagine that our transaction is an ATM withdrawal. Two things must happen for this transaction to complete. First, the cash has to be withdrawn, and then a debit operation must take place on the account owner. If one of these operations fails, then the transaction cannot be completed. The consistency says that a transaction cannot complete if it violates data constraints or corrupts the table. Practical examples are if primary keys are violated due to duplicate values, an attempt to insert invalid data, or common size exceeded during an insert operation. The isolation is about data concurrency. SQL Server has a mechanism to protect data such as locking and transaction isolation level. One classic example is when a transaction is doing an operation that modifies data, an exclusive lock is placed and all other users processes attempting to browse or update a table may have to wait until the original transaction is complete. And finally, the durability. Every transaction must be durable, that is, it must be written to the transaction log so it has the ability to roll back if necessary. Now that we've finished reviewing the internal components on SQL Server architecture, let's take a look at the versions and editions. These are the SQL Server versions currently in the market. SQL Server 7 is extremely rare, while the 2000 version not that much, as still some legacy application runs on this platform. SQL Server 2005 to 2008 R2 are the majority in place nowadays, while the new family 2012 and 2014 are growing, and we have the SQL Server Azure, which is the platform optimized for the cloud. The most common editions in the are the Enterprise and Standard. The Enterprise is often seen in more critical environments, as this is the most complete edition and it has almost no limitations, while the Standard is cheaper but it has some drawbacks. If you want to know the technical specifications and limitations for each edition, the best place to look is the books online from Microsoft. So here are some of the characteristics of each version. Starting with SQL Server 7 and 2000, SQL Server has an introduction. This version, the failover clustering high availability feature, being able to support mission critical system, but has had some troubleshooting limitations at that time. The SQL Server 2005, 2008, and R2 offered a great expansion of functionalities and also the introduction, the DMVs, which are dynamic management views in SQL Server 2005. These are great for troubleshooting purposes, as many internal data was not available on the previous versions on SQL Server 2000. It also introduced the SQL Server Management Studio, which was the evolution of the Query Analyzer, the main interface used by the DBAs. And finally, the new family, the new generation of the product, SQL Server 2012 and 2014, it offers the always-on high availability feature, in-memory processing, column store index, and it's a cloud-ready platform. These are some of the other features available in SQL Server, such as the analyzer services for data warehousing, reporting services, and integration services. These features, they are selected during the product installation, but are out of the scope for this course. Now let's take a look at our first demo named First Steps with SQL Server. If you are already familiar with SQL Server, or if you are already a DBA, you might want to skip this slide. I will demonstrate some of the very basics of SQL Server for those who haven't seen it yet. So this is a Windows 7 environment, as I will use it as a test lab for the course. I am accessing now the SQL Server Configuration Manager to verify the active services. In this case, here is my SQL Server instance named SQL Trainee, the SQL Server Agent, and the browser. You can see the state, both are running. The start mode manual, meaning that the SQL Server will only start when I issue a command to the console or to the interface. The logon as, which is with account from Windows, is controlling the SQL Server instance. In this case, Nick is the account name that is using it. So we can observe here the state, start mode, the service account, and if I right click here, I can enter the commands. I can check on properties. As you can see, this is the service account being used. It's a local Windows account, or I could use the built-in account, which is not recommended but still works. Here's the service, mentioned which binary path the SQL Server installation was located. My computer name, which is in this case Nick PC. SQL Server name, the process ID on Windows. The start mode, here I can change it, I can disable, set to automatic, which is start with the Windows, and disable. Current state. Startup parameter is at a more advanced setting that we will not check now. This is used during troubleshooting on critical situations. Sometimes we need to start SQL Server with less resources, to use less memory, or to start in a single user, but it's just for your awareness. But for now, it's okay just to view these options. I'm going to hit cancel. Here we can also have the client configuration. We can see actually the client configuration, the protocols, configure TCP/IP ports, but I just wanted to show you this interface, which is more recommended than if you use the standard Services.msc console from Windows, because this configuration manager, it only lists the services that belongs to SQL Server, not other services from Windows, so you have less chance to commit any error when dealing with this interface. Now I'm going to show you the SQL Server Management Studio. This is the initial screen that you will be prompted to choose the Windows or SQL Server Authentication mode. Here we have the computer name, in this case Nick PC, and I'm choosing Windows Authentication. Here is my SQL Server instance name, SQL Training, and I'll just hit connect. So this is the Object Explorer. I'm going to expand a little bit here to the right, where you can also see here, it's my user currently login, that is Nick PC, it's the computer name, and the Windows name. And here is the product version, 11.0.3000, that is SQL Server 2012 with Service Pack 1. This might look very simple, but is useful when you are working with several instances at the same time and connecting with different users. So you can actually see the Service Pack version or the SQL Server version when dealing with multiple servers at the same time. These are the system databases, which will be covered in Module 4, Master Model, MSDB, and TimpDB. Now, if we hit New Query, you can observe this tab here already shows my session number, which is 57. There's another tab open, 51. I'm going to close it for now. If we click on View Properties window, it also shows the same information. It's very basic stuff, but for the beginners this is very useful for you to situate on SQL Server, like in which instance you are running the command, what is your SPID, the server process ID, the SQL Server version, and this information I have already told you. The username you are connected, Windows name, and SQL Server instance name. This option in the drop box here is used to change the context of the database of your current session. So notice we were on master database, and here I can change, like for MSDB or TimpDB. So the commands I entered here on this part, on this query, they will be targeted to the database that is specified here. I can do this using this drop box or by command, which we are going to see on the next exercise. So let me close this properties window here, and let me open the exercise on this new session. I'm going to close the 52 one. So if I try to give this command here, select star from dbo.backupset, which is a system database, it's going to say invalid object name, because this table only exists on the MSDB database. I can change it from here or using this command below. use MSDB Go will change the context of my current session to the MSDB database. Now the select will work. This is the result of a metadata table that contains backup information. It's not relevant to see these columns right now. So let me erase this stuff here and continue the exercise. I'm going to go back to the master context, use master go, and let me select the following information from the sys.databases table from the master database and hit execute. Notice that I'm only running the code that I selected here, which is highlighted in yellow. If I just click here outside and hit execute, it's going to execute whatever it's written down here. So I don't want this. I just want this piece of code. I'm going to select execute and it will work. This is a simple display from some standard options for all the databases, system and user databases existing on my SQL Server. I just wanted to give you an example of a simple transact SQL query. Now I'm going to open a transaction explicitly with begin trend command. I'm going to hit execute. I'm going to use tempdb to create a temporary table, name it movies. Let me expand this. There we go. Create table movies with 3 columns. There we go. And I'm going to load some data into movies. 3 movies: Gladiator, Dark Knight, and Predator, as well as the movie year. There we go. 3 rows affected. And now I'm going to browse the data I have just inserted. Notice I am on tempdb context, which is where the temporary table was created. So I just selected this piece of code, and this in green, it's a comment. So whatever I write here, it's not going to be executed. So we have the movie code, movie name, and launch here. And I'm going to update the data by correcting one small information here. The movie Predator, it's not from 1950, it's from 1987. So here's the update. 1 row affected. I'm going to browse the data again, just this piece of code. I can include another comment, it makes no difference in the result. So here it is. I'm ordering by movie year. So we have the Predator, Gladiator, and Dark Knight. And then I'm going to commit this transaction. I could commit or roll back. So I'm going to just commit transaction. It works. If I try to commit it again, SQL Server will tell me there is no corresponding open transaction with this request. So this commit transaction request has no corresponding begin transaction. So this is very basic stuff, but I wanted to show you that. So if you are not aware of how SQL Server works, the main interface that the DBA uses, this is the SQL Server Management Studio, and these were some very simple commands where we browsed information from the sys databases and created temporary object that is a table here, and inserted and updated data inside of a transaction. Let's proceed now to the next module. Module 2, SQL Server Security. In this module, we are going to briefly view the most important security aspects of SQL Server. And they are authentication modes, server and database level roles, and the service account. This is the shortest module of the whole training, because this is just an overview, but do not underestimate the security importance. The following images will illustrate a little bit about the security aspects I just spoke in the previous slide. So we have here our SQL instance, some databases, and the tables. And this login has 2 ways of accessing SQL Server, either using Windows authentication, which is where the user is not prompted for any password because the login is the same used in the Windows server locally or through the Active Directory. And then we have the SQL authentication, where the user needs to input his or her password, because in this way the login is created inside SQL Server and does not interact with the operating system. The SQL authentication is normally used by third-party applications that require connection to the database server. And there are the server roles applicable for the whole instance, such as Sysadmin or Security Admin, and some other roles applicable only at a database, in this case user or system database level. That could be DB owner, data reader, or writer as some examples. And finally, the permissions can be on schema level. The schemas are object containers and are commonly used to avoid conflicts with objects with similar names. And a single login can have multiple users related to it. From a DBA perspective, the Windows authentication mode is easier to manage since the passwords are out of the control of the DBA and the users may change themselves through the Windows. While with SQL logins, the DBA can change many settings, including the password, like password policy enforcement, password expiration. So the decision of leaving one SQL Server instance with Windows only or mixed mode rely on factors such as the application requirements from the client or technical specifications from security policies. And whenever you change the server authentication method, you need to restart the SQL Server to take effect. The Sysadmin is the most powerful privilege a user can have in SQL Server. As the database administrator, you should be very careful when granting Sysadmin access to user or a group of users. This is because the shared administration can bring harmful consequences to the SQL instance, such as the ones I'm going to show here next. So these are some of the risks: shared administration, accidental or intentional deletion of critical objects, changes to backup jobs are just some of them. The best practice in this case, when a user requests sysadmin, is to evaluate the situation and determine a lower privilege that fills the requirements. I have seen before cases where the client asked for sysadmin to perform simple tasks such as user database management, creating or dropping tables. The DB owner permission was in this case more than enough, so you need to consider that the client sometimes may not be very technical, and he or she asked the DBA for this privilege because someone else advised them to do so, because it was more convenient. So it's the DBA duty to determine what is the real privilege required based on the technical specification on what exactly the user wants to do in the database server. The service account is a Windows login used to run the SQL services, just like I showed previously on the first demo on the SQL Server Configuration Manager. They can be changed at any time but requires a SQL Server restart to take effect. If this account does not have the necessary privileges, SQL Server may fail to start with access denied error, or it can even start, but at any time that an interaction is needed with the operating system, such as to perform a backup, it can throw errors. For a clustered environment, the same rule applies. The account, if it's part of a specific Active Directory domain, must have the required privileges. This image shows that NT/MS SQL Server is being used as a service account. This type of login is created during the product installation, and it's not a good practice to leave them like this. Instead, you should be using either a local Windows login or a login that is part of a domain. Let's take a look now at some security activities inside SQL Server. So the first command I wanted to show you here, it's the validate authentication mode, this query here. This command is a store procedure that tells me which is the current authentication mode running on my SQL Server. In this case, it's mixed. So we accept here Windows and SQL Server logins. It's the same thing. I can check if I right click here on the instance, then properties. I'm going to expand the security tab. As you can see here, server authentication, it's marked with SQL and Windows authentication mode. Another option I wanted to show you here, it's the login auditing one. Here we have faded logins only. This means whenever someone tries to access my SQL Server and the login fails, maybe because there was a bad password or the user did not exist, it's going to remain a record in the error log. So this is useful evidence if you are tracking unauthorized access to the SQL Server. The best practice is to use this option, both failed and successful logins. And instead of clicking OK, I'm going to click Script and Script Action to New Query Window. Then I'm going to close this. I wanted to show you this because whatever options you change through the interface here on in Management Studio, if you click on Script, you can pick up the code that is executed behind the scenes. Then you can run by yourself and see what actually you are doing in the interface. So if you like more to write codes or T-SQL, this is the best option for you. And maybe if you are not so familiar with T-SQL and want to use the interface, it's the same thing. You can just do whatever you want in the interface, or can script everything to command. I'm going to execute this. There we go. Let me close this tab now. Move on to the second one. Here I'm going to create the Heisenberg login using the master database, create login Heisenberg, a password, and let's take a look at these options now. The default database is going to be tempdb, so whenever this user logs in, he's going to see the tempdb database. I'm checking on the check expiration option and the check policy. These are Windows options, Windows policies, so I'm saying this password will expire from whatever amount of days set on the local policy. Let's say it's 90 days or 60, and it's obeying the security policy, the password policy, which asks for specific characters, numeric or special characters. If I turn this off, my user is going to be created anyway, but it might be a security deviation whenever I run a health check. So let me create this, and now I have just created a user without any privilege. Let's take a look now what this guy here, Heisenberg, can do. I'm going to access again the SQL Server, selecting SQL Server Authentication. The login's already saved here, so I'm going to hit connect, and as you can see, a new session has opened. This one here that I was using, it's logging on with my user Nick, and this now it's Heisenberg. I'm going to right click here, reports, standard reports, and I'm going to select a standard report here like server dashboard to see if this user can actually see anything at all without any permissions. Let's take a look at what happens. You see there's a lot of red messages here saying the user does not have permission to perform this action over and over. So if I try again, let me pick another report like job connections, it's still going to fail because my user does not have privilege. I created an empty user without any server permission role or user database permission role. I'm going to close these screens. Let me go back to this session for Heisenberg. I'm going to try to expand a user database here. It's going to give me an error. Database is not accessible. I can even expand here some system database, but they don't work. I can even expand master stuff here, but this is just related to my local user. I'm not going to be able to change anything, create a table, create user, nothing. So what needs to be done is I'm going to go back to my other session here. Now I'm going back to Nick user, and I'm going to add a privilege to Heisenberg. So outer server role, sysadmin, add member, Heisenberg. Hit execute, and now this user, he has access to the whole SQL Server. Let me try again here. Standard reports, server dashboard. Now it's going to work. As you can see, it provided me some performance reports as I selected. And if I try to create a new table here, database, whatever I want, I will be able to do so. So let me go back to the exercise, option number 3. Again, on the Nick user, I'm going to drop Heisenberg from the sysadmin permission. There you go. And I'm going to change the permission from sysadmin to setup admin. Hit execute. And before I go back to that user, let me check here something. I'm going to expand security, logins. There is my Heisenberg. Let me refresh. There we go. Right click, properties. If we go to server role, you can see it has setup admin checking in. User mapping, it does not have any because I didn't select so. Let me hit cancel. And another things I wanted to show you here is these users right here, the NT servers / something. These are all created during the SQL Server installation. So these are automatic users. These are my Windows login, and the SA is specified also during the SQL Server installation if I select mixed mode as the authentication method. So let me collapse security database. I'm going to go back to Heisenberg session, right click, new query. Note that I am now on spid number 56 on Heisenberg login. I'm going to try to read the error log, and hit execute. Let's see what happens. It says only members of the security admin role can execute the store procedure. So what I did before was change the permission from sysadmin, that was the top one, from setup admin. But it still cannot simply read the error log because it requires security admin. So each permission level that we seen on the previous slides, they have a specific function. And only the sysadmin is the most powerful one that can do whatever you want. Okay? So let me check here now the exercise number 4. This command, it's a simple select statement where I'm going to expect users with sysadmin privilege. I'm going to hit execute. So everyone, almost everyone on my SQL Server has sysadmin, including these accounts that were created during the installation, my Windows user, the SA, and their default database is the master one. Some security policies may consider this as a security exposure, and they may require you to change this from like TimpDB or MSDB, because master is the most critical database in SQL Server, and we're going to study more about this on module 4, database structures. The last item I wanted to show you in this demo is the security health check. This is a whole script that's going to perform a validation in the SQL Server instance for some security aspects according to a security policy from a client. So let me just execute and I'll show you what it does. It basically printed a report here with my instance name, the build version, the date of the scan, and it's going to validate some aspects according to whatever the client wants to add to their policy. So depending on which client you are working on, the policy may be stricter than others. Okay, depending on the industry you're working on. If you work on the financial industry or maybe a small company, their security policies may be different. So here it's validating the SQL Audit logins. So it's logging all events. It says it's compliance. That is the option I showed you earlier about failed logins and both failed and successful logins. Here's the log retention. I'm going to show you about the error log for SQL Server on the next module, the health check one. So it's not okay. It's asking me to change the SQL retention to 99. Validating built-in administrator, says it's compliance because it doesn't exist. Built-in administrator, it's an account that it's created. Sometimes it's created during the SQL Server installation, and it should be removed because whoever has administrator access privilege on Windows may access SQL Server as well. Guest user existence, it's considered a best practice to remove all guest users. Ownership training. Validating enforced password, says here all logins has enforced password on. And the SA login says not okay. You need to either disable or rename this SA login. So this is a very specific security policy because for whatever reason the client wanted to have no logins named SA on this SQL Server. So this is very specific, but it's just a sample I wanted to show you for this demo. Module 3, SQL Server Health Check. A basic health check in SQL Server can be done by inspecting the overall aspects of the SQL instance, such as database status, critical errors, the SQL error log, or active connections. It can go even further by combining it with operating system checks, such as CPU or memory utilization, active jobs in SQL agent, blockings, top running queries, and more, just to name a few. For now, we will limit to some common situations such as services status. So a basic health check can be done through the graphical interface or Transact SQL, and I always recommend Transact SQL over the display-only checks because they can generate quick evidences, and these can be valuable for critical situations where the DBA must act promptly. Common statement from the customer or even end users is that the SQL database is down or the whole SQL server is down. Sometimes we need to be aware that the customer or end users may not know the difference between a SQL instance, a user database, so if their applications throw a generic error, they will claim the SQL is down, and that's okay. It's the DBA duty to determine what actually is down and act on it accordingly. And here, I am just reinforcing what I stated in the previous slide. Do not rely on the interface as it can be tricky sometimes. And there are a variety of techniques to be used, and we will look into each one of them in the practice at the end of this module. The database console commands are very useful for troubleshooting purposes and health checking as well. The DBCC CHECKDB is one of the essential ones that should not be missed, because its output will indicate if there is corruption on your database, and it's considered a best practice to run it before starting a backup and after a database is reinitialized or restored. One point of attention, however, is that CHECKDB can take a very long time to finish for very large databases because it generates a snapshot during the execution, and the process could be aborted if the database is running out of internal space. So if you do not want to run DBCC CHECKDB for the whole database, there are some variations such as the check table, where you can check the consistency only for a specific table inside your database. There are situations during a health check where the DBA will have to inspect which users or processes are connected to a SQL instance to narrow down the search for the cause of an ongoing issue. There are some different commands for this, from the oldest one that produce raw data such as spwho or the sys.sys processes table, and we have the refined dynamic management views that are useful for troubleshooting with a more deeper level of details, such as checking reads and write per database files, index usage, average CPU usage of each query. I'll show you some example on these commands at the end of the module. The eventvwr is a classic Windows Server log where critical errors are recorded, such as hardware failures, memory alerts, or services stopped and started. For most situations, they are useful at the starting point of an investigation when performing a health check on a Windows level. The SQL Server error log stores a variety of data from informational messages to critical errors, mostly related to the product and physical infrastructure, such as database offline, corruption, database space issues, transaction log full, and others. And it can be customized to display further errors, such as deadlock graphs or application-specific messages. Inspecting the SQL Server properties is also essential to know the behavior of a SQL Server instance, especially if there are recent changes to it. Common settings that are more frequently modified are parallelism, maximum server memory, backup compression, and audit level, just to name a few. There are much more, and this can also be browsed using spconfigure, a system-level store procedure. A blocked process happens when a server process ID, or a spid, attempts to perform an operation and is blocked by one or more spids. And a deadlock event is when mutual blocking occurs, so SQL Server chooses one of these spids to terminate it automatically. Let's take a look now on a graphical representation. So here we have a spid updating a table named client, and at the same time in a parallel transaction a different spid is updating the store table. So at this moment there is no relation between these two transactions. But now the first spid will try to update the store table and it will be blocked. And finally, the second transaction will try to update the client and it will be blocked as well. But since it is a mutual blocking situation and this spid was the one who caused the mutual blocking, it will be chosen as the deadlock victim by SQL Server, which will terminate the process automatically. And here are some examples on locks on SQL Server. There's a shared lock used in read operations such as select statement, exclusive logs for when a transaction is modifying data, the update lock, which is sort of a temporary lock that converts itself to exclusive when the row to be updated is found, and then Deadlock. There are many others, and a good source to look into them all is the SQL Server Books Online. Now in this demo, I will show you a variety of commands that can be used during a SQL Server health check situation. So let's get things started right away. So these are the queries that are going to be used on this exercise. I'm starting with number 1, basic info. This is a built-in function named server properties where we can inspect SQL Server data. I'm going to execute it. There we go. So we have the Windows Server name, the edition of my SQL Server, in this case Enterprise Edition 64-bit. The SQL Instance name, in this case I'm using SQL Training. This is called a named instance. So I defined a specific name to my SQL Server during the installation. If I don't specify any name, the standard name, it's MS SQL Server. So this is a named instance. Here it's showing me that it's not clustered, so the value is 0. It's showing me that SQL Server 2012 because the build is 11.0, and the current service pack level or product level, in this case service pack 1. So this is a good script for you to run when you are getting to know a SQL Server instance that you started to support, or if you're logged in an environment for the first time. Now the second one, healthcheck.sql, it provides more information. As you can see, the piece of code is larger, it has some condition checks, and this one will print the information in a more friendly format when I execute it. So we have the status check report, SQL instance name, when the SQL Server was last restarted in the server time zone. It says is the standalone SQL Server, calculates the SQL Server version based on build level. In this case says me it's 2012, it's correct. Service pack level, the edition, again the Windows Server name, and it also checks the database status. System and user says that always online. So if we had a SQL Server restart, for example, and whatever a database is not coming online, this check can pick it up and show it here. How many user databases we have and the status of the SQL Server agent as well. So we have more information here, and it's useful because it's in a text format and you can use it to show to your client or to save it as the evidence on an incident record. Moving to the next script, get uptime. I'm going to run this so you can see SQL Server it's online for 0 days, 0 hours, and only 14 minutes because I just started it a few minutes back. So you can ask yourself why this is relevant, why such piece of code it's relevant to a DBA. So imagine yourself in a situation you are on a critical incident with your client in a conference call, and you as the DBA may be asked, hey, for how long the SQL Server is running? For a week, 2 days, 1 month? With this code you can access this information right away. So sometimes even the smallest piece of code or simplicity can be very effective. So you can have this information right away, and it can help you to isolate the possible causes of a problem, because you can say, hey, this SQL Server it's online for like 2 months or 1 month, some weeks, whatever. So you can start to isolate the problem cause by having this kind of information at your hand in a very fast manner. The next one, it's hardware info. This is a script from Glenn Barry from SQLskills.com, and it will show me basic hardware information. Just like the first one, this is good for you are getting to know a SQL Server instance or maybe perform a capacity baseline. So you need to know physical memory, CPU count, processor information, it's all here. So it's another information that you can retrieve right away using Transact SQL. Script number 5, I name it here as complete status because it has even more information than the other one I just showed. So let me hit execute, and it's, as you can see, it's similar to the other one, and it has just a little bit more details. So check it data, the host name, SQL Server Edition, if it's cluster, product level, last startup, let's calculate the uptimes, the version of SQL Server, if reporting services installed, the current port that it's listening, where are the binary paths installed. So let me show you, it shows me here the system, the log paths. Let me expand this to show you. There it is. See if we can have this basic information right away. And the service properties like the service account, the startup mode for the SQL engine, and the SQL Server agent. You can get the service account here. In this case, I'm using Nick as my user to run SQL Server and both agent. Okay. Now let me show you spconfigure. This command useful to check the properties on SQL Server. So if I right click here to the interface and click properties, I'll have general, memory, processor, a lot of things here I can see or even change. But instead I'm going to show you by command first. So let me do an spconfigure. As you can see, 69 rows affected. Sometimes if you run this command without doing this first, show advanced options, it will display only a limited amount of information. So I have executed this before, show advanced options equal to 1, which is I'm turning on this option. So the spconfigure show me all available data that I can modify here. I can change thresholds, values. So let me adjust the memory to 512 megabytes. I'm running spconfigure, name max server memory in megabytes, and I'm putting the value 512. We configure it, override, and go. And now change it from 4 gigabytes to a half gigabyte. If I go here, properties, memory, there we go. It's already updated in the properties. So that's just an example of settings you can change using spconfigure. I can also change backup compression using this command. There you go. Actually, I'm going to change it to 1 because it was not enabled. So let me show you here first. Properties, database settings. You can see compressed backup. It's not enabled. This was a feature that was started in SQL Server 2008. Let me close this. So I'm going to enable backup compression. And let me inspect how it is now. So run value 1 means it's enabled. And if I go back here again, properties, database settings, as you can see, it's marked the checkbox. The next one is the DBCC commands. So here I'm validating the consistency for the MSDB, which is a system database. So here's the command string. It's very simple. Execute. You see that the output is very large, but don't worry, what we need is on the very bottom. SQL Server would check all the objects on this database. You see a lot of sys.named tables because those are system databases, and at the very bottom you can find what we need. So CheckDB found 0 allocation errors and 0 consistency errors on the database. So here's one example where it worked without any problems. So let's take a look now at how is the output of the command when a database has some sort of problem. This one, you can already see the exclamation sign at the bottom, query completed with errors. So let me scroll down here a little bit. And these are the errors occurred, table errors. And if we go to the bottom, SQL Server says CheckDB found 0 allocation errors and 4 consistency errors in the stock database. And it already recommends what it thinks that it will fix the problem. So it's recommending a repair command with allow data loss. So DBCC CHECKDB, the database name with repair with allow data loss, it thinks that it could help to solve the problem. So depending on which level of problem it finds on the output of the CheckDB, it will recommend you an action. Sometimes, depending on the level of corruption that it finds, it will even tell you to restart the database from a full backup or do a repair. So another type of variation for the command is the DBCC check table, and I'm including on this string all the error messages should they occur. Using the wrong database, let me switch to MSDB, there we go. No problems found. He just returned the check. And this is another classic command. I wanted to show you the SQL perf log space, another DBCC category command. It will check all the database on MySQL Server, the transaction log size, and how much percent of this log is currently used. We're going to talk a little bit more about the transaction log structure in the next module, database structures. Now to the DMVs. The dynamic management views were introduced back in SQL Server 2005, and they are very powerful as you can check a lot of information, such as I wrote here, operating system info, performance data, indexing. You can pick up information from active users, active sessions, and queries. So you can mix up different DMVs in the same piece of code, so you can retrieve information from real time on what's happening with SQL Server. And before showing them, I'm going to present some old commands, some what I call legacy commands, that they still work, but they do not produce the refined data that we can check with DMVs. So let me select everything from this table, the sys processes one, and as you can see, it's not very filtered, so you can see a lot of columns, such as what the process is actually doing, the username, and there's a lot of data here that's not readable unless it's formatted. We can do this with DMVs, hostname, physical I/O, how much CPU each process is consuming. And in SQL Server, every SPID, every session server process ID that is higher than 50 means a user process. So here I'm filtering this information but still using the raw data from the table, like so. And there's the SP who true, who show me basically the same information but with some filters. You can see there are less columns than before. The SPID, status, the login, hostname, if it's blocked or not, the database that he's using, the command. As I said, these guys here until the 50 on the SPID number, they are system processes, and these others starting from 51 to 62, they are user data. Now let's take a look at some DMVs in practice. So this code would get a count of SQL connections by IP address and host name. Since this is a local lab, there won't be much connections, but just so you can have an idea on how the output is. So I'm filtering the DMV sysdm exec sessions with sysdm exec connections, and I'm putting some filters. So you can see the host name, it's my computer, how many connections per user, what is the program that is using to connect. So we have Management Studio, an open query, and the SQL agent that is active. I'm going to inspect now some running queries by using DMV exec requests, exec connections, and sessions. Let me execute it. Okay, there's only one running. And this one would track uncommitted transactions. This is from Paul Render from SQLskills.com. There's none, but let me run a workload here. Check that it show you. Okay, now we should be able to see something. There it is. 2 transactions, user transactions, 56 and 57. The database that they're running, and these are not yet committed. So we are able to see this. They're doing inserts on user databases. We are only able to see them by combining data from DMVs. DM transaction, DM database transactions, exec connections, exec requests. So there's a lot of them available. You can see in the documentation from books online the whole set of them. So we just wanted to show you how powerful are the DMVs if we apply the right filters to them. You can also inspect backup information using them. So let me process a backup on the archive database. I'm going to run this command to start a backup, and here we have the backup duration using DM exec requests. I'm putting a filter on the command that includes backup, and I will be able to see how many minutes are left for the command to complete. So here it is, session number 55. It's running a backup database on the archive data, and around 7 minutes to finish. The next topic to look now is the SQL Server error log. The error log is nothing more than a text file that you can open with Word, WordPad, Notepad, whatever text reader you want to, and the physical location of the file we can check with this command using the server property built-in function. So it's in the standard path here: program files, SQL Server, the SQL instance name, and on the log folder. We can read it through Management Studio if the error log is not very large in this case, because imagine a production server where an error log is huge. I have seen a case where it had like 250 gigabytes because an application was producing so many messages in a loop that the log was growing until it reached the maximum disk size. So it was impossible to execute this command and read it using SQL Server. It would stop my session. So make sure you know the size of the physical size of the error log before running this string. Now here's a sample on how it looks like. In this case, these were the events logged when the SQL Server was starting. As you can see here, startup parameter, the service account, the authentication mode. These are evidences that the SQL Server is starting. How many gigabytes of RAM the operating system has, and many other technical data. I'm going to close this Object Explorer so you can see more of it. There it is. Starting the databases, many messages. The CheckDB that I did before, it's here. The login succeeded. Remember that option we configure on the properties for the auditing. Login succeeded, and a lot of other messages. DBCC CHECKDB, whatever. So let me open again the Object Explorer. This next command will change the amount of error log files that are retained from 6, which is the default value, to 99. According to the security policy, depending on the client you work with, you are required to change this number to the maximum amount, which is 99. And it's even considered a good practice, because as much error logs you have, the more error logs you have, it's better for you to have evidences on what happened to your SQL Server. So if I expand management, go to right click on error log configure, you can see that it's set to 6, and I can change using 99 here or running this command. So the more logs you have, it's better for troubleshooting. We can recycle the error log should it get too big. Maybe you want to archive your error logs, you want to delete old and unneeded files. You can recycle, so SQL Server will produce a new file. You just run this command sp cycle underline error log, and if you read it again, you'll see that it's much smaller now than it was before, and you need to look for this message to know that it was recycled. So the error log has been reinitialized, and there you have a small error log. We can also use the SP error log store procedure to look for errors inside it. So let me look here for DBCC on the error log number 1, which is the previous error log I just recycled, and let it see if it finds anything. There it is. It found DBCC strings using this piece of code. That was the evidence. There it is. So in the error log, what you mostly see are physical related errors related to the database infrastructure. So database full, transaction log errors, database brought online, database brought offline, users connected, users disconnecting. Let me give you another sample here. If I go here to properties, security, you can see the auditing. It's getting both failed and successful logins. So let me do a test here. I'm going to try to connect to SQL Server using a login that doesn't exist. Let me put Heisenberg2 and whatever password. Hit connect. Show me an error. I'm going to try it a few more times. Then hit cancel, and let's look at the error log again. Login succeeded, and then there is the login failed for Heisenberg2. Could not find a login matching the name provided. So that option is useful for us to have in the error log the evidences that someone tried to access the SQL Server. So you can track unauthorized access, or you can do problem determination using this information. Now the last step is the blocked process 1. I'm going to close the error log and the previous DMVs, and here it is. To start this one, I'm going to create two tables. The first one is host country on tempdb. These are the host countries for the previous soccer World Cups. There we go. And the other table will be the finalists, 2 teams for each year, creating the table and inserting data. And this is where I'm going to run the block simulation. I'm going to close this for now, open the process, blocked process left, and then the right. Let me split the screen, vertical tab group, there it is. So what I'm doing is I'll be opening 2 explicit transactions using the begin trend. So starting a transaction here and this. Now the first transactions will update the host country and set name to Brazil, where the host here is 2014 because Brazil was the host of the last World Cup. And I'm correcting this information in the table. There is 1 row affected, while the second transaction is going to update the finalist table and set the second team as Spain, which is one of the finalists in 2010. There it is. So far, no relation between the 2 transactions. But now, the first transaction is doing the same thing as I did here in the second. So he's also trying to update Spain. And note that my screen got blank here. So this guy here is blocked. So spid number 52 is blocked by 55. As you can see, the query is marked as executing, and we remain there. If I right click here on my SQL Server name, reports, standard reports, all blocking transactions, I'll be able to see it. Let's wait for it to load. So here it is. It's transaction ID, some properties, the blocking SQL statement. Let me open like this. There it is. Full transaction. This is what is blocked. So let me close it. And now On the second transaction, I'm going to produce a deadlock because there was already a block in here, and on the second transaction, I'm going to update the host country set name to Brazil, just like I did here. So SQL Server will understand that the second transaction, spid 55, caused the mutual blocking, and it will be terminated. Take a look. Execute, and only a few seconds later, this guy here is terminated. There it is. So transaction process ID 55 was deadlocked on lock resources with another process and has been chosen as a deadlock victim. So I'm going to roll back this guy here. Oops, it's already rolled back. I'm going to roll back this one. Now let me close these two guys and open a block check. I'm going to run a script to produce some more blockings so we can see the display using transact SQL instead of the interface. There it is. So look at how simple is this code. So I'm using the legacy table, not even using DMVs. I could be using, but that is just to give you a quick method of retrieving blocking data. So the current speed, who is blocking it, last wait time, the database login time, and program name that is used. In this case, I'm using a DOS prompt to access the SQL Server using SQL CMD. So it says here, program name, SQL CMD, and the command that is being ran by each transaction and my login. So there's a delete statement and one update statement. 56 being blocked by 57, and 57 it's being blocked by 55. If I go here again in reports, all blocking transactions, it will be there as well. So there are many ways to check for blockings. There's a blocking statement. I put a wait for delay 2 minutes. This was intentional to produce the waiting and the blocks. If I expand the transaction, these are the details of who is blocking who. So you can either check this by interface, you can schedule a job in SQL Server Agent to capture blocking data, you can run scripts to verify for blockings like every 5 minutes or every minute, every hour. You can configure alerts to fire up whenever a blocking transaction remains active for a certain period you define. So these are just some methods I wanted to show you on how we can check for blockings and the difference between a blocked process and a deadlock. Module 4, Database Structures. First, I'd like to show you the 4 system databases that are shipped with any copy of SQL Server. These are vital to the core operations of a SQL Server instance, especially the master one, because it contains metadata, which is system data for critical operations, such as logins, user database mappings, and many others. Backup, restore, and SQL Server agent related tasks are stored in MSDB, while the model database serve as scheme for creating user databases because they pick up the same setting that is defined on the model. And finally, there is the tempdb one that is heavily used by applications and production servers as they deal with temporary objects. The tempdb, it is critical for the workload of a production applications using the SQL Server, and it is the best practice across the market to isolate its data and log files from other databases, so they do not compete for I/O resources and have the performance optimized. There are many articles and even books about how to configure properly tempdb for different workloads, and there are many options for tuning it, so consider this just a glimpse on tempdb content. And another important fact to mention is that tempdb, the size of it, is reset whenever the SQL Server restarts, so there is no backup or restore of this database. And on these black boxes you can check some examples on objects stored by tempdb. Next, I'm going to show you the file structures of a SQL Server database. Any database must have at least one data and transaction log file and their extensions are the .mdf and LDF. And there are the secondary data files as well, and the log files, but these are optional and you will not see them on every database. It's really a matter of design according to each database particular need, according to each application need. And finally, there's the file group concept, which is a logical layer where you can assign specific files to put into. The default is primary. And what is the content on each of those files? The data files, as the name says, it's where the tables actually are in the format of data pages. And the function of the transaction log is to maintain the records of each operation that modified data, such as inserts, deletes, or update. Now to the autocode properties for the log and data files. Both data and transaction log files, they must be able to expand themselves if required. This can be achieved with the autogrowth properties that a DBA can configure to tell SQL Server how to deal with each file, whether it will grow in a percent or by megabytes or gigabytes, whatever. And if there is going to be a limit or not for this growth. Now, for this question, which autogrowth option is better? There is not really a single answer for this because it depends on your workload. It depends on your environment. In my particular experience for production servers, I see more often the autogrowth set to a specific amount of megabytes instead of percent. This is because if you set to a certain amount, say 10%, and your database is very large, something like 1 or 10 terabytes, every time there's a need for expansion, it will be 10 gigabytes, leading to the file physically expansion increase, so it will consume additional storage without having the need to do so. Now, for the next 4 slides, we will look into some aspects for the transaction log, as it is a key component of the SQL Server databases. Remember the first module when we looked into the asset properties. The D stands for durability, and this is what the transaction log does. It allows a transaction to roll back and allows SQL Server to revert changes that were done to a database by keeping track of everything that was changed with the backup of these logs. The transaction log consists of virtual log files, and these are constantly being reused. We will see a little bit more about them on the next screen. It is also good to remind that the transaction log is sequential. The error 9002 is a classic when dealing with transaction logs. Eventually, you get at least to see one if working as a production DBA. We will see it happening on the practice demo. Here at the second bullet, I have highlighted the top reasons that a transaction log fills up. Active transaction or missing log backup in case the database is in a full recovery model. When it is such a simple recovery model, the truncate of the virtual log files, which release internal space, happens with a checkpoint when the database log space reaches 70% full. I'm going to present some more details about the recovery models on the next slides. And here in the final bullet, the statement is that there are no performance gain when creating multiple log files because they are written sequentially. And here is to emphasize the fact that only one virtual log file is active at a time, no matter how many of them exists inside the transaction log file. The other ones are marked as inactive, while only one is in use, and this table shows the amount of ELFs exists according to each file size. There are recent changes to these numbers on SQL Server 2014, but they will not be covered in this course. However, if you are interested in checking about this, I recommend to take a look at Paul Render's blog on SQLSeals.com. Now, in the last slide about the transaction log, I wanted to show you some internal components of a log file structure. These concepts are not commonly used in day-to-day troubleshooting, but it's something worth to be aware of. So each virtual log file has log blocks inside it, and each log block has 60 KB max. And inside every log block we have the log records. And on every log record we have the actual data changes that happens inside during the transactions. And notice that a single log record can hold changes from different transactions at the same time, as each one of them is unique. And this is how SQL Server keep track of everything using the LSN, which is the log sequence number, to identify every operation. And in the case some action requires to be reverted or reapplied, that is, rolled back or rolled forward, SQL Server is able to do so. Now, moving forward on this module, I wanted to present you the shrink file considerations. I wanted to emphasize this command as it can be tricky sometimes if you are unaware of the consequences, especially when using it on production environments. So I'm going to exemplify through some images next. Let's imagine a database with a single data and log files. And on the data file, we have physically 1 GB of size and 99% of internal free space. Then we have an insert operation that fills up 80% of this internal storage, leaving 20% of free space. Notice the overall physical size remains the same because it has not yet reached the limit, so we're not considering auto growth on this particular example. After this, let's consider there was a delete statement that wiped out the recently data and let the data file with 80% of internal free storage. I'm not considering here changes to the transaction log file because delete operations are costly, so I'm not considering these now, only the data file. And at this time, the shrink command takes place in attempt to reduce the data file physical size to save disk space. And let's assume the command worked, but it has a cost, index fragmentation, that we're going to see in the next demo. So here's the overall summary. The shrink file operation in data files can lead to several index fragmentation and can degrade performance by slowing down the query's response time. The larger data file is, the longest is the time for a shrink file command to work, and it can even enter in conflict with other operations, such as backup, if they're running at the same time. I have seen situations where a shrink file ran for up to 10 hours in production servers, and this must be used only as a last resource. Instead of having to reduce data file physical size, the best method to avoid such scenario is to have periodically data purge or archive to avoid uncontrolled growth. Should you run in a situation where the shrink data file is required, make sure to communicate with the client and consider a time frame for rebuilding or reorganizing the indexes right after. The shrink on log file does not have the same impact as the transaction log, has only tracking data. However, if used with frequency, it means the capacity surrounding the transaction log should be adjusted. Either the disk where it's located should be expanded, or the application using the SQL instance should control the excessive log growth by reducing the volume of costly operations such as deletes and considering bulk logged recovery model, periodically data purge, or other actions. Now let's take a look at the database recovery model options. When we create a new database or adjust the properties of an existing one, the recovery model plays an essential role because it determines how the database will behave in regard of the backup capabilities. So here we have the full recovery model. This is the most common to see in production servers. It allows the transaction log to be backed up, so in case there's a need to revert the database back to a previous state in time, this can be done by using the transaction log backups. And we will learn more about point-in-time recovery on the next module. Next, we have the bulk logged recovery model. This one is used on specific situations where huge data loads are being generated and it generates less activity in the transaction log as possible. So it's more like a temporary recovery model to be used in certain cases. And we have the simple recovery model. It has some limitations as it does not allow log backups, and it's commonly used in databases that are not updated with high frequency, such as reporting databases for read-only purposes or databases where a full backup is more than enough to comply with business needs. And there are many other adjustments that can be done in a single SQL Server database because many properties are available. And here I'm going to highlight a few to be considered. Here we have the auto create and auto update statistics. These must always be turned on. If they're turned off, it means that the DBA will have to manually keep the statistics up to date, and this is not a best practice across the industry. We have also the auto shrink and auto close, and their dangers also be turned on because they affect your database availability, and you have little control over the data file structure. So make sure that if you see one of these options turned on, you have a very good reason to keep them like this. Now let's begin the demo for this module, where I'll present you two exercises. The first will be creating a new database, inspecting the properties, changing the auto growth settings, and producing some common errors we see on production servers. And on the second exercise, I'll show you the impact of the shrink file on a data file in SQL Server to see how it causes index fragmentation in a database. So let's get things started. So here is the first exercise. The first step is to create a new database, and there's a comment here. I mentioned that for this exercise I'm doing, notice that I am putting the physical data and log files on the root for the C drive. So the service account running SQL Server must have administrator rights on the C drive. So these are the settings that I'm going to use on this command. New York data will be the logical file name. Here's the physical path. Initial size 100 megabytes. No autogrowth. This is intentional for us to produce the errors. And the transaction log will be on this path also. And here's the logical file name. Same thing, 100 megabytes without any growth. Let me hit execute. There it is. And I'm going to inspect the properties using the graphical interface. Right away you can see there's no database or log backups because we have just created it, so this is normal. If we go to files, there is the exact information we put there in the command. The file name, the physical path, C drive, no autogrowth or max size specified. The initial size is 100 megabytes for each file, so the database overall has 200 megabytes. The file group for the primary data file, and the logical name. Another thing I wanted to show you here is the option tab. We commented earlier on the previous slide about the auto close, create statistics, auto shrink, and auto updates options. And as you can see, auto close it's turned off, create statistics turn it on, auto shrink turn it off, and auto update turn it on. As you can see, there are many other options here, and normally these settings, they're only changed when the application or when your client requests the DBA to do so, because these are very specific to the database behavior, and generally when you create a new database they come just like this by default. Okay, so let me hit cancel here. Before that, let me show you the recovery model. This is where we check. As you can see, the default is full because in the model database that serves as a scheme for new ones, it has the full recovery model. So it picks up from the model. We can change here from simple and bulk logged. But for now, I'm going to leave it with full. I'm going to hit cancel because I was just inspecting the properties. Nothing was changed at all. The second step is to create some tables. I'm using here this data type char 80,000 bytes because it will cause my database to fill up quickly when I insert data next. And this code, we are going to use it to monitor the data and log free space. As you can see, overall size of the database 200 megabytes, unallocated free space almost 98 megabytes. This is the free space inside the data file, and the usage of the data file in megabytes only 2.5, and the transaction log almost near to 0. Number 4, I'm going to fill up data until I produce an error on this database. So I'm creating here an infinite loop while 1 equals to 1. I'm going to insert data until the capacity can handle. It will take a few minutes for this to complete, so I'm going to pause the video and return when the command completes so we can see the error and start the troubleshooting based on it. So here's the error that was produced by my script. Could not allocate space for object. This is a table and primary key in database New York because the primary file group is full. So basically, SQL Server is telling us that the data file inside this primary file group is full. And it already mentions here some workarounds to correct this problem. So create this space by removing unneeded files. You can drop objects in the file group, add additional files, or change the autogrowth settings. And before we explore these workaround options, I'm going to show you the monitor space script again. Before, remember, the unallocated space was almost 100 megabyte, and now almost nothing, because the data file space used in megabytes equals to 100. The log utilization also increased. So let me go back here to number 5, workarounds, so we can explore the options that SQL Server gave us. The first one, here I'm adding a secondary data file, name it New York Data 2. Here's the logical name, again the physical path. I'm giving 50 megabytes for this one, restricting the autogrowth to 100 megabytes and allowing 10 megabytes of expansion to the file group primary, which is the only one we have. There it is. So if I run the monitor space again, look at the unallocated space and database size. Of course, it has expanded, and now we have 50 megabytes of free space, and the database size just increased. But the data file, first data file used, that I'm checking it here, New York data, still has 100 megabytes full. So another workaround to reduce it is to delete data from the tables, and this will provoke the 9002 error that I commented earlier in the transaction log section. So let's run this, and right away you can see an error shown to the screen. Transaction log for database New York is full because of an active transaction, which was this. So if I try to check this now, I will not be able to find any transaction because it rolled it back as it completed with errors. So the delete statement has a very high cost to the transaction log because it has to record everything on it in case there's a rollback. So these type of operations are very costly for SQL Server and cause the log to grow very fast. And since our transaction log has no autogrowth, as we've seen here, no autogrowth for the transaction log, it causes this famous error. And this command I wanted to show you because it's normally used to verify whatever it's holding the transaction log from truncating. When the transaction log truncates its internal virtual log files, the log space is reused. And sometimes if there's an active transaction here, or log backup means you need to take any actions. But since our transaction that caused the error already rolled back, there is nothing here. You can also inspect the SQL perf log space for the New York database. You can see the log size almost reached the limit, 99 megabytes, but from this current size, only 5 megabytes are in use because it truncated itself after the rollback. Third workaround, I'm going to purge the data using the truncate. There it is, completed successfully. Let's take a look at the monitor space script again. Once more, there it is. Now unallocated space 147 megabytes, and you can see the data file space used for the primary data file reached only 2.5 megabytes, just like it was at the beginning. So what is the difference between the truncate table and the delete statement? The truncate does the same as the delete, but the difference it has a lower cost to the transaction log than the delete statement. It still has information logged there, but in a very different manner, so it wipes data in a more fast way. But you should be careful when using it in production. This is only a lab. Now let's go to the fourth workaround. Let's enable the auto growth settings, outer database, New York, and modify the file using file growth to allow the transaction log to expand itself every 1 megabytes. And let's see what happens. I'm going to reset the exercise now and pause the video so we can actually see what happens to the transaction log after the delete statement works without any errors. Alright, so I reset the exercise, and now instead of doing the first and second workaround and third, I'm going to directly go here and change the auto growth for the transaction log file to 1 megabyte, and I'm going to try to delete the information from the tables and see what happens. I'm going to pause the video now and return once the script is completed. So there it is, the rows affected. Let's take a look now at the monitor space script once again. You can see log file space used in megabytes. My transaction log has now 179 megabytes. And look at the database size, already expanded, because the delete operation, as I mentioned before, has a high cost to the transaction log. It's a best practice recommended by many articles. You'll find this on SQL Server books, that when you are purging data from the SQL Server and you want to delete data from very large databases, you do this from time to time and split the process. Otherwise, you're most likely going to run in a transaction log error, just like we did here. Now moving on to the next exercise, this is the shrink file demo. I'm going to start by creating a test database, name it shrink test, just like the previous exercise, without any auto growth. Transaction log here on C drive. There it is. Another script to monitor the database space, just like we did before. Okay, so we have 100 megabytes database, almost everything unallocated, and only the data file space used we are concerned for this exercise. Now I'm going to create a table named heavy load, and I'm going to insert some data until the limit allows. So let's wait a little bit for this script to run. I'm going to pause the video now and come back a few seconds later after the command is completed. So here is the result, the command completed without any errors. If we look at the monitor DB space again, now we have 1.38 megabytes only of free space, and the shrink test data file reached almost the full capacity. The next step is to check for the index name. Since I have created the table with the primary key, SQL Server automatically generated a cluster index. And I'm going to check for this cluster index fragmentation level by running this. You can see it's below 1%, so it's not a concern right now. And I'm going to intentionally purge some data to see what happens. It should only take a couple of seconds. There it is, the rows affected. If I go back here, oops, it's at this. Hit execute. Only 0.10% of increase, so still not a concern. But now, let me shrink the data file to see what actually happens. And before I go to do this, I'm going to inspect the properties again for the data file. You can see 100 megabytes, shrink data. Let's run this. Okay, the command completed. Let's inspect what happened here. There was a 40 megabytes reduction for the physical size of this shrinkdata.mdf data file. If we inspect the properties again for space, you can see the database size now 120 megabytes, but the shrink test data file space usage only 58. And the reason for this growth was because the transaction log has expanded. If we hit properties, and files, you can see 62 megabytes for the transaction log, but it was before 1 megabyte. So the log has expanded as well. That's why my database overall size increased. Now let's take a look at the fragmentation level after the shrink for the cluster index. See, there's a huge increase from less than 1% to 45%. That means a lot. And in production servers, when we deal with very large databases and a very large amount of cluster indexes or non-cluster indexes, this level of fragmentation can cause performance degradation by slowing down query performance. So let me pick the index name again. This. I'm going to run a reorg index, changing the index name. So outer index, the index name on table heavy load. I'm going to rebuild it, see what happens. It's going to give me a space error because the primary is full, primary file group is full. Because the rebuild, it's a more costly operation for the transaction log and for the data file other than the reorg. So I'm going to use reorganize instead to reduce the fragmentation level. Let's check it here now. Remember, it was 45%. Now, after the reorg, let's check what happened. Back below 1%. So we had to do this to recover the status after the shrink. Or we could have done this. Autogrowth settings, change the autogrowth settings for the shrink data file, and then run a rebuild. So the most important message from this exercise is, whatever you do this in production, imagine a very large database. The shrink file command could run for a couple of hours. I've seen situations where it ran for like 8 to 10 hours. And after that, you need to have a window available on your server, an outage window maybe, to run a reorg or rebuild indexes on the whole database that you executed the shrink. Otherwise, you have a huge fragmentation level and the users can feel this impact since their queries are going to be slowed down. This is the module 5, Backup and Restore. These are the backup options available for the SQL Server databases, and for this training, I'm going to give emphasis on the full, differential, and transaction log ones, as they are the most common to see in the industry. The full backup has no secrets at all. It only saves a copy of the whole database, and it's mandatory for the other types of backups to work. So you cannot have a transaction log backup or a differential one without having a full backup first. And like every other task in SQL Server, it can be done through the graphical interface on Management Studio or Transact SQL. And I'll be demonstrating some backup commands soon in the practice demo. The differential backup contains all data that was changed after the last full backup, and it will overwrite the existing log backups if any was taken. It will also append to the previous differential backup set, so every new differential backup will have an increased size by default. This type of backup is recommended for very large databases that cannot be backed up on a daily basis. By having a differential backup set available, the restore process may be convenient under specific circumstances. The transaction log backup, or simply the backup of the log, is usually very small in size compared to the full or the differential one, because it only saves the recent changes from the transaction log file. This type of backup is used for point-in-time restore, that is, to revert the database to a specific time in the past in case this is necessary. One example can be to revert a production database to the past state after a critical table was deleted by mistake. So, if this table was dropped at say around 11:30 p.m., it may be possible to return the database prior to this operation took place at 11 p.m. if the log backups are available. And for the databases that has transaction log backups in place, they are usually set to run between small intervals, such as from every hour or every 30 minutes. It really depends on the business requirements and on the type of the database. The transaction log backups also form a log backup chain, which we'll be able to see next in a few moments. Now the copy-only backup, it is a type that does not interfere in the current backup chain when executed, and it's often seen during simple migrations or when the DBAs simply want to get a copy of the database without interfering in the current backup and log chain. A common backup plan in SQL Server can be like this. Starting at midnight, we have a full backup, and every 30 minutes there's a log backup until a differential takes place at 4 a.m. I'm considering this as a large database. This could be different. It really depends on the business requirement and the service level agreements with your client. And this backup plan, it can be applied to all user databases, or it can be applied to some specific user databases, and even for the system databases, but without the log backups, of course, and differential, because the system databases, the master, MSDB, and model, they require only a full backup because it's more than enough in case you lose them for whatever reason and you need to restore them. And this backup plan can be done through SQL Server agent jobs. You can schedule and plan it to happen according to the time you want. We are going to see more about the SQL Server agent in the next module. Next is an overview of a restore sequence, in this case point in time restore sequence for 2 a.m. Let's consider here a database where the client requested you as the DBA to revert it back in time to 2 a.m. because let's say at 2:15 the client accidentally deleted a critical object, so they need to revert this back to 2 a.m. The first step to do is to restore the full backup taken at midnight, and then simply we are going to obey the sequence from the log backups in the order they were taken. So we leave this database open for restored all the log sequence until the desired time. In this case it's 2 a.m. These guys here, number 1 to 5, they form what we call the backup chain, and the log ones, they are the log backup chain. So if I go ahead and delete one of these log files, my log chain is broken and I will no longer be able to do a point in time restore. Now let's take a look at the differential one. Same timeline, same procedure, but let's say now I want to revert my database back to the most current state, and let's consider also now it's 4:20 a.m. So I need to go back the database to 4 a.m. Simply I can restore the full backup and then restore the differential backup. So I'm going to bypass all these log backups here. This is the advantage of differential backup. It's a larger file than the log backups, but it's easier to restore depending on what do you need. If you don't require like a point in time restore to a specific time frame, the differential backup may suit your need. The tail of the log, it is an interesting concept related to crash recovery. It is considered a best practice to back up the tail of the log so you can attempt to fully recover a damaged database back to the prior state, and under some situations the SQL Server will even do this by itself through the interface before you try to restore. That is the case with the version 2012. This tail of the log, it refers to a portion of the transaction log that was not saved on the last log backup before the SQL Server crashed for whatever reason. We can even force it to occur if we use the continue after error option. Let's see how it works now. On this backup scheme, let's consider the last log backup finished at 3:02 a.m. and 14 minutes later an user deleted by mistake a critical table and was unable to revert that change, so that was at 3:16. And to make it worse, SQL Server crashed at 3:27 before the next log backup. So all the activities logged in the transaction log between this period, 3:02 until 3:27, they were not saved. This is the tail of the log that needs to be backed up, so we can attempt to fully recover the database even having the information that was not saved before the crash. These are some of the concepts and options available around the restore commands. We will be able to see them very shortly in the demo. The restore header only, it is useful when you are validating a backup file before a restore. There are options, no recovery, that leaves the database open to receive more log backup files and replace, so you can overwrite the current database log and data files. And SQL Server also keeps track of every restore operation by logging them into a metadata table in the MSDB, name it Restore History. This table indicates recovery models reference and the types of backup a database is allowed to perform when using each one. Note that only the simple recovery model has limitations when it comes to log backups. And remember that for critical databases, such as the one with OLTP workload, point-in-time restore capability is critical, especially for financial or retail companies that deal daily with monetary transactions. If you see a database that is considered critical for business in simple recovery mode, make sure the client is aware of this setting and its limitations. And this is for the Dark Knight fans out there. The message is very clear. As the DBA, you must guarantee the backups are available, tested, otherwise you will be in trouble when a disaster occurs. After all, a database can be damaged or lost at any time, but unfortunately, every situation can get worse, and for the DBA, if you are trying to recover a damaged database and finds out there is no recent backup available, that is really a tough spot to be into. From now on, I will be demonstrating some of the content we have covered in the backup and restore module. In the first step, I'm going to create the movies database and set it to simple recovery model by using this string. There are some prerequisites for this exercise, such as creating a folder in C drive and making sure the SQL Server is running with a service account that has administrator privilege. There it is. Now I'm going to perform a full backup to disk on the movies database. There is the string. As you can see, this is now a backup device. This file, if I go ahead and try to backup movies again to the same, using the same string, another backup file will be inserted into this backup device. So this is a backup device with a single backup file for now. Let me inspect now the database properties. There we go. Okay. Database name, status is online. Here's the backup location. I'm retrieving this information from the system database MSDB, as you can see here. I'm joining information from the sys databases to the MSDB metadata from the movies database. So I want to see the backup location, the physical file location of this backup device, the backup size in megabytes, the finish date, indication if this backup is damaged or not, the recovery model that the database had when the backup was performed, and some other properties. SQL instance name and the type, in this case D, it's not for differential, it's a database backup that is the same as full backup. If we try to perform a log backup on movies, this is going to happen. The backup log is not allowed while the recovery model is simple. Use the alter database command to change the recovery model. So we can do this using the command or doing through the interface. Let me expand. Here are the movies, properties. I can come here and change this simple to full or bulk log it. But this time I'm going to show you through the transact SQL. Simple as this. Use master and alter database movies, set recovery model full. with no wait means it's going to do this right away. There it is. But if I try to back up the log again, remember that I explained it about the importance of the backup sequence. Backup log cannot be performed because there is no current database backup. So you may be asking yourself now, but we did take a backup first. This one, right? Yes, but after we change the recovery model, we just broke the backup sequence, the backup chain. So we need a new full backup to attempt to perform the log again. So here it is. I'm changing now the file name, movies underline full number 2.back, and the backup log, it's going to work now. There it is. Moving on to step 4, if we inspect backup metadata from MSDB backup set table, let's look at the begin log chain column, and as you can see, the first log backup begins the log backup chain, which is equals to number 1, and type its log backup. We took 2 full backups, 2 different device names, and then the transaction log backup from movies database. More 2 log backups here. And let's inspect the data once more. There it is. Did you notice the difference here? These guys, they do not begin the log chain because, of course, it began in the first log backup. So they belong to this backup here, the full 2.back, but they do not start the sequence. They are part of a structure that starts on this one. So if I go ahead and delete one of these, my log sequence will be broken. And this is the differential backup string. I have already entered this command and it worked. All you need to do is put the width differential on the command string, but at this time we're not going to use the differential backup set. So I just wanted to show you the string. I'm going to move on to the restore sequence. Remember that previous slide when I showed the restore options. One of these options were the header only command. I'm going to use restore header only on the second full backup, on this backup set, and it provides me a lot of metadata information, only the header from this file, such as the database name, the user, SQL Server name, the backup log sequence number, how many megabytes or whatever size it is, backup start and finish date. There are a lot of options here, and I could keep going on, at least 30 different ones. But the point here is to verify if the file is valid for a restore. In this case, we have a full backup, and there's one particular option very useful. In this case, is damaged equals to 0, means my file is not damaged, so it's good to process in a restore. But the only way to actually have 100% sure if it will work is to actually do the restore. This is what we're going to do next. Here is what we are going to do next. I'm using the previous backup file, and I'm going to create the movies new database using the original full backup. So restore database, new name, movies new, from disk, that location, file 1, that is the only file that is inside this backup set. I'm going to change the file name and location, assigning a new data file.mdf and a new log data file. So here's the logical name, changing the physical location. The most important now, it's the no recovery option, because I'm going to leave the database in the restoring state. That is, it will remain open so more transaction log backups can be applied to the sequence. There we go. If I go ahead and refresh my studio, there it is. Movies new in restoring state, and the other database remains intact. So I just created a new database. Now I'm I'm going to restore the log backups in the same sequence they were taken, just as I explained it before. Restore log, database name, from disk using the first log backup and still specifying no recovery because I want to keep the database in restoring state as I have more than one log backup. There it is. Second log backup restored, and finally the last one. This, I'm restoring the database movies new with recovery. I'm simply putting it back online. Refreshing the database, there it is, it's ready to use. And one interesting data is to check the information from that metadata table. I have mentioned it before, the restore history from MSDB. There it is. I restored the full backup, then I restored 3 transaction log backup files. Before moving to the next step, I wanted to show you the restore sequence, but now using the graphical interface. Databases, restore database, it's very simple. Source will be a device. I'm going to add now the full backup and the 3 log backup files that were taken. Here it is, movies full 2 back, and the 3 log backups. SQL Server prepares a sequence for the restore. Here's the restore plan. You can see on this dashboard the log sequence numbers. I'm going to change the database name from movies to, say, production new. Okay. If you see this message here, the explanation is a tail of the log backup of the source database will be taken. In this case, the source database is the movies. SQL Server understands there might be data still in the transaction log before this operation takes place. So as a guarantee, it backups the tail of the log in case I mark that option in the options page, which I'm going to show you very shortly. Before that, let me go to Files and reallocate this information on the SQL folder. And I want to rename the data and log files to prod2 and prod2 underscore log. Logical file name will be the same, rows data and transaction log. Here in the options, I'm going to restore the database with the recovery, so it means I will bring it back online as soon as the restore finishes. And here the option to take the tail of the log backup, and here leave source database in restoring state. I don't want that. I don't want the movies database to be affected, so I'm gonna click here, go back to general, and script this action to a new query window asking me to connect. Here it is. This is the batch that SQL Server prepared for me to run this restore. Similar to the one we viewed, but with more parameters. And if I execute this, let us see the results. Here it is. Refreshing. Production new is available, and the source database where I used the backup from, movies, still available. Moving on forward, we have exercise number 8, tail of the log, where here you have a clear vision on how the process works. I'm going to use the client database without any specifications for the demo. And inside the client, we will use the top brands table to exemplify what happens on the scenario. Okay. Number 9, I'm loading data and performing some backups. First, I'm going to insert 2 values on top brands table. So the first column is the company name, and the second is the business that the company sells. So we have IBM and Microsoft, 2 rows affected. The first full backup. Okay. Now the second transaction I'm inserting 3 values: Target, Starbucks, and Sony. There we go. 3 rows affected. And now the first log backup. My third transaction has Walmart and Adidas on the top branch table. Again, the second log backup. The fourth transaction inserted in BMW and Wilson. And finally, the third log backup. Okay. The last transaction, LG, MGM, and soft layer. Good. Now we are going to inspect the data we have just inserted. So the expected result is 12 rows. Here they are. Everything good so far. Now I'm going to simulate a crash on the client database to see what happens. Here I am forcing it offline using the rollback immediate command, so any uncommitted transactions will be rolled back and the database will be put offline. Only after that I can go ahead and remove only the primary data file, the client underscore data, and I'm using a shortcut to perform this. It is the same thing if I go in the Windows Explorer and right click the file and hit delete. There it is. If I try to bring the client back online, let's see what happens. There's the error. Unable to open the physical file. Operating system error 2. The system could not find the specified file. This is on Portuguese because my operating system is not in English, but translating it's the same as the system could not find the specified file. And if I go to the error log, it will also accuse that error. Scroll up a little bit, there it is. Starting up database client, there is the error. Could not open the file missing. But notice the transaction log was not touched, so it's still there. Let me try to restore now the database client to a name client underscore new using only the full backup. Restoring database client new from this backup set, changing the data file name and transaction log file name, replacing the current data, and using recovery. Okay, I'm going to refresh. There it is. The client, the original database, it's in recovery pending, and I'm not able to access it, as you can see. And here we have the client new. But if we take a look at the top brand table, top brands, only the first 2 rows, because all the other data we inserted was after the full backup. I have to use the log backups to leave the database, to recover the database to the state it was before the crash. Let me put the client new in single user to avoid interference from other connections, in this case my own connections. And now I'm going to restore the same thing I did here, but using the no recovery. Okay, refreshing the data. As you can see, client new is restoring, but still not available. Okay, I can check this using the command as well. There it is. We have the client in recovery pending and the new database client new in restoring. Now I'm going to apply the transaction logs in the sequence they were taken. Let's see what happens. Okay. Let me see the database status again. Client new, it's okay. It's ready to use. I can expand all the objects here. But if we query the top branch table, only 9 rows. There are 3 rows missing. They are still in the transaction log database as I wrote here, and they are in the tail of the log. They are in the portion of the transaction log that was not backed up before the crash. So I'm going to try to back up the log of the original database. Client is going to give me this. Backup client cannot be opened. There are inaccessible files, or there's no memory or disk space, and see the SQL Server error log for more details. We already know what's going on. Okay, we have deleted the primary data file, but I'm going to force the backup of the tail of the log to happen using the continue after error option. There you go. Again, altering database client new to single user, and I'm going to resume the restore sequence, applying the database with no recovery until here. Okay. Meanwhile, I'm going to refresh. Okay. Client new and restore state. Finally, this is the tail of the log backup being applied. You can see here on the file name, I'm putting with recovery, so database will be brought back online. Now the top branch should have the expected 12 rows. In summary, this is what was done. The fifth transaction that contained the last 3 rows, it happened after the last log backup and before the database crashed, so the information was pending back there, and this is the real capability of the tail of the log. You can fully recover a database state as it was before the crash. If there were no tail of the log backup, let's say that your most recent log backup were the first one, and imagine now a production very large database with thousands of rows. All these data would have been lost without the capability of tail of the log. So that's why it's so important on the crash recovery mechanism. The last item from our list is number 12, inspect log chain. Here I wanted to show you some more practical data on the log sequence number so you can have a better picture. Filtering by the client database, I'm selecting data from the backup set metadata from MSDB database. There it is. If you notice, the first log sequence number of the full backup equals to this column, database backup LSN, from all the log backups I took, including the tail of the log one. The first one begins the log chain, that's okay, that's expected. And if you observe here, the last log sequence number for the first log backup equals to the first log sequence number in the next one, and on and on. What I wanted to show is, if we remove one of these backups, in this case the second one, I have already entered this command, so I'm not going to process it again. What happens to our sequence? Let me try to restore the full backup using now client backup as the new database name. The first log backup is going to be restored without any errors. The second is going to say you got a missing file. The operating system could not find the client_log2.trn. That's intentional. And this is the error I wanted to show you. The log in this backup set begins at this LSN, which is too recent to apply to the database, and then SQL Server says that an earlier log backup, which include this LSN, can be restored. If we pick this number and put in our first query, I'm going to put an end clause, first LSN equals to it. It will point which file is missing. So this is useful when you are in a production environment and for whatever reason you have a missing log backup. You can keep this track by using the metadata from MSDB. Before wrapping up the backup and restore module, which is the one I consider the most important for this training, I wanted to give some final considerations. The first one is try to test your backups, try to validate these backups if available, especially for production service. Imagine you are in a situation where a critical database is corrupted or damaged, and when you have the most recent full backup or even a log backup, it is corrupted for whatever reason. That's a very tough spot to be into, and it will be very hard to explain to the client why was that backup not tested before? Why are you keeping a backup that is not valid? So consider testing the backups if possible. The second bullet, consider using options such as backup compression, checksum, and there are many other parameters you can use on the backup database command available on books online. Do not underestimate the system database's backup, especially the master. We spoke a lot here about user databases backup the transaction log, restore point in time, but do not forget to full backup all the system databases, of course, except the tempdb, because if you lose the master database, you'll be in trouble if you don't have a full backup, because it contains metadata. Remember from the module 4, it contains metadata from logins, it contains information from the user databases, and that's a big problem if you don't have a backup and the master is corrupted. Have a monitoring on your backups. You can use third-party tools. You can use scripts you get from the internet, from the good sources. I explained it in the introduction module. You can apply backup reporting by running scripts through the SQL agent and exporting the data to Excel so you can quickly take decisions on which backups are failing. Research about other methods of backing up the SQL Server databases. There are third-party softwares that can back up SQL Server databases to a cloud server or to specific media or even for disaster recovery purposes. The last one, know the backup service level agreement with your client, such as the retention period for the backup copies, how long they will keep on disk, how long until they are sent off-site, maybe to a tape device. Know which recovery models are being used. Communicate with your client. If you are using simple recovery model for a critical database, explain that point-in-time recovery it's not possible, and make sure the client is aware of this current setting should they have any database and simple recovery model for critical purposes. This is the module 6, SQL Server Agent. The agent is a feature that already ships with all SQL Server versions except the Express one, and is responsible for allowing jobs to be created, scheduled, and monitored, and it also has some other functionalities such as creating customized alerts for specific events. Every job in SQL Server must have an objective, and it starts manually through transact SQL command or using the graphical interface. It can be also started by schedule, which is also specified by the database administrator. Some common job types found in a production environment are archive or purge data from user tables, running executable files from Windows, audit access to objects from specific users, and much more. Remember module 4 when we reviewed the purpose of the system databases. So here is again the MSDB. It saves all jobs metadata such as dbo.sysjobs. The database administrator can also monitor the job's execution in real time using the SQL Server Agent Monitor, or of course using transact SQL commands like DMVs, which we reviewed in module 3. You can also apply filters to the graphical interface if there are several jobs on your SQL Server and you want to get a quick report on what is failing, what had succeeded, what is enabled or disabled. And the output file from the SQL Server agent can be browsed to a notepad or the graphical interface. It's located on this path that it's on your screen. The maintenance plans are an alternative to creating jobs using a standard graphical interface other than the conventional method, as you can create a single maintenance plan to have multiple jobs inside it, like performing each one a different task, such as backup full, backup log, consistency check, and rebuilding indexes. I'll be demonstrating very shortly the difference between using the standard way and the maintenance plan one. Here is the pattern for a SQL Server agent job. Everyone must have a valid name, A login should be as owner, and the status is either enabled or disabled. A disabled job is only able to run if executed manually by the database administrator or from a user with privilege in SQL agent. If a job owner login specified is a user without the appropriate permissions, the job will fail. And the job must have at least one step where you specify the type and output settings. The most common type is to run transact SQL statement, but there are others as well, such as replication tasks, integration services package, operating system command, or PowerShell scripts. When you have multiple steps, you configure the behavior of each one in the event of success or failure, whether it will continue to the next one or quit the job execution. In the output settings, there is the option to either include the job step history in the job log or save the history in a text file. And a schedule is applied according to the frequency of each job run, such as daily, weekly, or at a specific date, and the intervals like every 1 hour or once a week. It can be set to run after a single event, such as when SQL Server Agent starts. Finally, for every job there is the possibility of configuring an alert to be sent for specific events, and pagers to be fired for emails. The data in the squares represent each system table in MSDB that saves job information, steps, and schedule metadata. They are used when retrieving job data for reporting purposes. In the next demo, we are going to look at basics for job creation, configuration, and output monitoring. To start, I'm going to add some jobs to my SQL Server without specifying any properties, just the job name using the sp at job system store procedure. So we have the integrity check, backup system databases, backup user databases, audit logins, and purge data. These names were randomly chosen. I'm just going to deal with one of this list, which will be backup system databases, so you can actually see how it is inside SQL Server Agent. Hit execute, and if I expand the SQL Server Agent tab, here they are in the jobs folder. I can also open the job activity monitor, and you will notice every one of them it's grayed out. Means they are enabled, but they have no step on it, so if I right click and try to start job or even stop, the option is not available. I have to configure more options inside each one of them. From this list, I'm going to pick up the backup system databases, hit properties, job name, the owner, it's my own login. Description here is optional. If I click on step, new step, I'm going to name it backup master DB. The type, as I said before, will be transact SQL script, which is the most common one, but there are others as you can see in the list. Run as, I'm not going to select any specific user. It will be targeted for master database, the command. You can select the option to put in another, but since it is a backup, I'm going to leave it on master. So backup database master to disk equals to that path we have been using in the other exercises. I'm going to name it master full.bak. Go. Before I save this information, if I click on advanced, I'm saying if this step succeeds, I'm going to quit the job reporting success. In this case, because I have only one step. And if the job fails, quit the job reporting failure, which is the obvious option here. General. Hit OK. Schedule. I'm not going to use it, but I'm going to create one just to show you. So let me name this daily master backup. Schedule type, I'm going to put it one time only. Selecting the date. Let me change this. I'm not going to put one time only. I'm going to put it reoccurring for daily every, say, 10 minutes. Start date. Without ending date, I can put an end date here, but I'm going to leave this unlimited. Here's a description of what I have just created. Hit OK. And target, I have to select target local server, otherwise it will throw me an error. And one option I forgot to mention was that one. You can put the output on a file, a text file, or log the information to a table, and finally include the step output in the history. I'm going to do this so you can actually see what happened after the backup finishes. Hit OK. OK again. Right click and start job at step, so we can see the results. Success. Right click, view history. Simple as that. Piece of cake, right? I click here, and there is my output saying the job was successful, and the backup output here. Processed 4 pages, blah blah blah. The backup database was successful. The SQL Server agent log can be browsed by using this option. You can select the current log or the archived ones, where I'll be able to see the jobs that executed and at what time the SQL Server agent either stopped it or restarted, and also if there are any errors that prevented SQL Server agent from restart. Now to finish, I wanted to show you the difference between the maintenance plan and the standard method to create jobs. In this case, I'm selecting backup databases, user, full, hit OK. Now the difference is these icons, that the toolbox that SQL Server shows me, and allow me to select some options to build a maintenance plan. I can start with check database integrity task, then I can drag a backup icon, maybe a rebuild index, and maintenance cleanup task to delete old backup files. On each one of the box, I can change the options to select what is exactly that I'm doing. This type, I'm doing a full backup, selecting all user databases. I can put the backup path here. The file extension can even view the transact SQL code that it was automatically generated and it will be executed once the job starts. So this is what SQL Server actually does. Hit OK. The same way you can do for the indexes. I can select the databases, all of them or specific. Check integrity task, same method. I can check all databases, only the system, the users. Once I finish creating the maintenance plan, it will be listing on the jobs on the SQL Server Agent tab, just like the ones we created. So it's more a convenient way to create. It really depends on your preference as a DBA. There's no right or wrong method, just a matter of preference. Module 7. High Availability Solutions. The high availability solutions available for SQL Server technology are built to help critical applications reduce the downtime of databases and also to prevent data loss by offering contingency methods. Let's take a look at some of them now. Failover clustering, log shipping, database mirroring, replication, and always on. While some of these solutions help to protect the whole state of a SQL Server, such as failover clustering, others are more focused on protecting the data itself by distributing it across other SQL servers. Now, you might be asking how to choose from this list what is the best solution. The answer is always depend on the business priority. For certain companies, data loss is not a concern, as the SQL Server may host a read-only database, for example. But downtime is a problem, while the opposite is also true. The below table is known for establishing a baseline between each service level agreement and the downtime of the product according to each level. As you can notice, the more aggressive is the service level agreement, less downtime is available for the DBA to perform tasks such as patching or any other maintenance that require the software to be unavailable. If we consider the fifth row, this level is almost 100% of service level agreement. That means if SQL Server stays down for over 5 minutes during a whole year, the commitment will not be made with the contract. And these two concepts are also fundamental to understand how to pick up the right solution for each business. RTO means recovery time objective, and it measures the amount of downtime a business can tolerate, while RPO, recovery point objective is concerned with data loss. The failover clustering requires at least 2 physical servers to take place. There are several configurations needed at both Windows and SQL Server level, such as setting up a domain controller and Active Directory, but those would not be covered here. Instead, I will provide a summary about how it works. Let's consider this scenario. One cluster node, or the primary Windows server, is located in New York, while the secondary is physically on Washington. There is a mechanism named isAlive that keeps checking each other to see if they are responding, just like a ping command. If one of the cluster nodes stop responding, and it's where SQL Server currently is, it will automatically fail over to the other. Consider that a physical problem happens in the primary server in New York. Immediately after this, the failover process takes place, and all resources, including SQL Server itself, the SQL agent, network IP, and others that may exist, are moved to Washington server. The log shipping is the easiest solution to implement and also the one with the lowest cost. This is because it has no special hardware requirements. If you have any version of SQL Server higher than the Express one, then you can configure and maintain log shipping. It provides redundancy on each user database level. This is how it works. First, we have 2 servers, one defined as a primary and a secondary, and before configuring the log shipping for the desired user database, it must have a full backup at least. This full backup must be restored in the secondary server, and a log backup can be restored as well, but that's optional. Then, a job on SQL Server agent will perform the log backup and copy this file to a network shared. That is a location where both servers have access to. Finally, another SQL Server agent job, but now on the secondary server, will perform a restore of this log backup file at a defined interval. The database in the secondary server will remain either in restoring or standby state until it is manually put back online. As you can observe, there are multiple phases until the log backup is replicated from one server to another, and factors like network latency, frequency of the log backups on primary, and frequency of the restore job in the secondary have a direct influence on this structure. That's why it's not the best solution if data loss is a concern. The database mirroring solution was introduced back in SQL Server 2005, and just like the log shipping, it provides protection on an individual user database level. However, instead of using log backups to replicate the data, it sends the transaction log records in real time, reducing the delays and allowing both servers' data to be almost or 100% equalized. There are 2 modes, the high performance and high safety, and it also allows an optional witness server to take place. In the database mirroring structure, when the primary server has any disruption, if it has mirroring configured, it will either manually or automatically fail over to the secondary server that will assume the role of primary. This is how it works in the high performance mode. First, there's a transaction happening in the primary server database. The transaction generates a log record, as we have seen back in Module 4 in the transaction log structure. The transaction is committed in the primary. After that, the transaction is sent to the mirror server. The log record arrives, and the mirror sends to the primary an acknowledged signal saying the transaction arrived with success. Only after that, the commit happens in the mirror server. So you can notice here there's a delay in the process to improve overall performance. Remember that in a production server, hundreds or even thousands of transactions can happen at the same time. Let's check now the events, but for the high safety mode that prioritize data synchronization, but require more performance to take place. So here is our first transaction again. Log record is generated. Now the transaction data is transmitted before the commit in the primary server. The log record arrives in the mirror. The acknowledge is sent back to the primary, and only after that, the same transaction is committed almost at the same time in both servers. This is known as a dual commit. It's a more efficient way to ensure data synchronization. So if your business prioritizes data loss, if data loss is a concern, then the high safety mode for the database mirroring is recommended over the high performance. The replication solution is different from we have seen in the log shipping and database mirroring because it focuses on replicating specific tables from a database instead of transmitting the whole transaction data or restoring log backups. This is the more complex to maintain than the others as it deals with logical structure as well. There are three modes, the snapshot, merge, and transactional. We're not going to cover them as they are out of the scope of the course, so instead provide a brief overview on how the replication works in some cases. Consider a company with a headquarters located in New York and some other offices in Texas, Arizona, and Florida. Each office has a local salesman who goes out in the field selling agricultural products on locations where there is no internet signal for whatever reason. He only uses a tablet to display and sell product to customers. There's a main database hosted in a server in New York location that contains the inventory of all available products and the current amount in stock. Once a new product has arrived, the main inventory database is updated, and this data is automatically replicated across the other offices, so the salesmen are able to show an updated product catalog to their customers. And after the local sales take place, each office has to update the local databases, then the data is sent back to the main inventory site. The Always On was introduced in SQL Server 2012, and it uses the same model of the database mirroring to transmit data, but instead it can do this for a group of databases called the availability group, which can contain up to 10 user databases. While it requires Windows Server Failover cluster installed, the SQL Server's primary and secondary can be standalone copies, and they do not need to share the same disks, just as a normal failover cluster structure. Here's a graphical representation. We have three servers, where in the always-on terminology, we call them availability replicas. One is the primary replica, one the secondary, and a third serve as a disaster recovery environment. On this scheme, we have two availability groups. Financial, that has databases credit, report, and cash, and funds, containing databases client, invest, and fund. Now suppose a critical failure happens in the primary replica. The availability group has to fail over to the secondary, and this will happen automatically or manual, as it depends on how the data synchronization was set up. For asynchronous data commit, the failover only happens when it's done manually with the allowed data loss option verified. This is because this option is more recommended when the replica is at a great distance, physical distance from the primary, just like a disaster recovery server, and data loss is not a primary concern. The synchronous commit provides full synchronization between the replicas, and there is no data loss, as the transactions are dual committed before they are considered complete by SQL Server. In the next demo, I will be demonstrating the configuration for the log shipping and always on. In this demo, I will show you how easy it is to configure and maintain a log shipping structure. The scenario for this exercise is the following. We have two different Windows servers, Node 1 and Node 2. Each one of those have a different SQL Server, a standalone copy. This one is Kratos. This will be our primary SQL Server instance for the log shipping. And on Node 2 we have Samus, which will be our secondary. So to start, I'm going to go here on primary, and I'm going to create the Joker database, which is the one we are going to use for this exercise. And I'm going to perform a backup of it to the SQL Share folder, which is a network share between the two servers. So the two servers, they can actually see the same folder. Let me run the script. Okay. Now I'm going to go to the secondary, and I'm going to restore the full backup. Before that, let me copy the file to the desktop. There it is, the Joker full.back. And I'm going to restore using the no recovery option, so the database is open to receive transaction log files. Let me hit execute. Command was okay. I'm going to refresh, and here we have the Joker database in restoring state. So now it's time to go back to the primary server and start the log shipping configuration. Let me disconnect this, and I'm going to refresh. There is a Joker database. Right click, properties, and I'm going to transaction log shipping option, and I'm going to mark the option enable this as a primary database in the log shipping configuration. The first option to change are the backup settings, and here I'm going to put the shared folder address, SQL share, that's it. And these are the threshold for file retention. So delete files older than 72 hours. This is by default. I'm not going to change this. Neither the alert option to alert me if no log backup occurs within 1 hour. What I'm going to change here, it's the job schedule for the log backup in the primary. I'm going to make it run every 3 minutes instead of 15. And I'm going to hit OK. Now it's time to add secondary server, which will be SSMS, just like that. Okay. The first tab is to initialize the secondary database. Since we did the restore in the database, it's already in restoring mode. We have the option here, no, the secondary database is initialized. So I'm gonna go to the next tab and the copy files destination. This should be a destination usually in the secondary server, which is in my case, so C user. I'm going to put it on desktop. I'm not going to change the delete copied files option, and I want this job, the copy one, to run every 1 minute. The last tab is to restore transaction log. So SQL Server gave us two options here: to restore the database in no recovery mode, so it will be in a restoring state not available to users, or in standby mode, where users are still able to read data. And I can mark this option to disconnect them when the restores are in process. These two options are for delaying the restores. By default, it's no delays. And alert if no restore occurs in the terminate period. By default, it's 45 minutes. I'm going to leave like this. And the job name will be this, and I'll change the schedule so the restore will take place every 5 minutes. I'm going to hit OK. OK again. Script configuration to new query window. I just wanted to show you this because it's the reason I'm doing in the interface. So it's more easy to learn step by step going through the graphical interface other than that whole piece of code. I'm going to hit OK. What's going to happen now, the jobs have just been created. Let's see under primary. So we have the alert job to alert me whenever the log backups are not occurring in the primary, and the log backup 1. On the secondary, if I expand the job activity monitor, there are 3 jobs. The alert to alert me if no restore occurs in the determined period, the copy job that will run every minute, and the restore 1. I'm going to pause the video now and go back a few minutes later to show you the results of the log shipping configuration. So here are the results for the jobs after some minutes of execution, and let's take a look now at the outputs for both copy and restore jobs on the secondary server SSMS. I'm going to right click here and view history. These are the output for the copy job, and from the restore ones you can see both were successful. And since the font here is very tiny, it must be difficult for you to read, so I separated the timeline of the events in a notepad here so you can actually read the output from the jobs. So here are the copy job steps. Here's what SQL Server does. It retrieves the copy settings, primary database, primary server name, picks up the backup source directory and destination. Here's the last copied file and the messages that says the copy was successful. And it also checks if previous copied log files are required. So it checks if nothing is missing to make sure the synchronization is okay between the primary and secondary. And this is the timeline for the restore job. Starting the transaction log restore, retrieve the settings. This is the file that picked it up on this specific job. I collected the output, and then it marks the restore operation as successful, and it says number of log backup file restore is 1. Now, one thing that's tricky during the troubleshooting of log shipping is sometimes there are no files to be copied or there are no files to be restored, depending on the time frame you configure as the interval for the routine to happen, for the copy job, for the restore to happen, or even for the log backup in the primary server. But even so, SQL Server agent will tell the job succeeded. So when troubleshooting log shipping, you need to make sure you look output by expanding each of the entries here, so you can actually see if there was a file restored, or sometimes it says number of file restored or number of files copied equal to 0. So sometimes your log shipping structure may not be working at all, but you still see the job succeeding. That's a false alarm. Okay, let me close this here, close again. These are all the log backups that are processing from the shared folder to my desktop. This is the secondary server. And refreshing the database. There's the Joker database in standby read-only status. And also, there's an interesting report. If we right-click here, in transaction log shipping status, it's a graphical report where we can actually see the latency of the files that are being transferred, the time since the last restore, and the SQL Server will tells us a status, if it's good or alert. If anything was wrong, it would be written in red here, and it would be like status alert. So the time since the last copy, the restore settings, latency of last file is 2 minutes, the threshold for the alert, we configure the alert if it's enabled or not. And if we go to the primary server, right click and run the same report, transaction log shipping, it will have almost the same information, but now for the primary standpoint. Let us take a look here what it gave us. This alert here was for a previous database Batman that I created some time ago, but I have deleted, so it's not relevant for this exercise, but it's just to demonstrate to you what happens when a log shipping is out of synchronization. And the Joker one is good, and here it showed me the last backup file that was restored, that was processed, correcting. So it says if the alert's enabled for the backup, the threshold for the alert, and time since my last backup. Now, before I finish the exercise, I want to show some considerations for the log shipping. I'm going to write here on the screen. So when troubleshooting log shipping, we need to make sure, especially in production servers, that things change. This was just a simple example on small databases. So things to consider are the frequency of the log backups in the primary server, the frequency of the copy log file job, the frequency of the restore on secondary, and also the database size where we are configuring log shipping, network latency, transaction log activity. Why? Because during huge database loads or maintenances such as rebuild indexes or bulk loads or whatever transactions are done by the application that causes the log to grow very fast, larger will be the log backups during this period. So it may impact the log shipping synchronization. So when configuring log shipping in production environments, you need to make sure that you agree with your client what are the required times for the service level agreements. Otherwise, you could not meet their expectations. So log shipping is considered a cheap solution because it requires no special environment like clustering or shared disks, no additional features to be installed. It's basically a backup and a restore process. So you need to make sure you consider these factors when configuring and maintaining log shipping in a production server. Now the last step of the exercise, I'm going to create backup job, a log backup job in this case, to run in a very frequent fashion in an order that it will interfere in my log shipping structure. So here's a job. It's going to perform a log backup of Joker database to a different location, and it's going to run every 4 minutes. So this way my log shipping structure will be broken very shortly, and I'll be able to show you what error is received on the destination server, the secondary one. I'm going to pause the video now and return a few minutes later so you can actually see the errors in the output for each job. So this is what happened after a couple of minutes. The restart job has failed, and let me take a look at the output here. Expand. And these are the errors. Again, I'm going to show you a notepad for a better view. This is what happens. SQL Server throws an error saying it could not find a log backup file to be applied to the secondary database, and the log backup file begins at set number this, which is too recent to apply to the database, and the restart log operation terminated. So what happened is the log change sequence was broken because there's more than one job performing log backups. So the log shipping synchronization was messed up. And if you see this case in production, you probably have to do two things. The first one is to actually verify why there's a second job performing log backups when you have log shipping in place. So you either need to remove that job or disable it, and then you are going to have to configure the log shipping structure again, because once the log chain is broken, the only way to restore this is by restarting the log shipping sequence and by taking another full backup so the sequence is reset. This is the demo for the always-on availability groups solution. We're going to use the same structure I used it in the log shipping demo. Here we have our node 1 with Kratos SQL Server, and on secondary node we have Samus SQL Server. They will both be part of our structure. I just wanted to show before I start a picture of the cluster we have. Both node 1 and node 2, they have no resources on it. This is where the availability group that I create is going to show up a few minutes from now. Let me expand the Kratos SQL Server, which is the primary availability replica. We have 4 databases: Captain America, Hulk, Iron Man, and Thor. They're going to be part of the availability group that I'm going to create next. Right click here, new availability group wizard. Let me expand. I'm going to call it Avengers. Next, I'm going to select the 4 databases to put on it. And now it's time to add the secondary replica. As you can see, Kratos is already selected as the primary one, and I'm going to add Samus as the secondary. There we go. Now some important configurations regarding data synchronization. You can see down here, for both Kratos and Samus replicas, the data synchronization mode is asynchronous commit. And that means the replica will use a synchronous commit, as it is written down here, and support only the failover with possible data loss. Manual failover with possible data loss for both replicas. So let's imagine the following scenario. The availability group is currently active on Kratos SQL Server, so it has the primary role on SQL Server Kratos. And if Kratos has a problem where the SQL Server crashes or needs to shut down, the 4 databases we just added, they are not going to move automatically to Samus. The SQL Server would need a DBA to enter the SQL Server Samus, issue a command saying, I want the databases to be failover, I want the availability group to be failed over with possible data loss, forcing a failover, acknowledging that a data loss is possible. So this kind of configuration is usually recommended for disaster recovery scenarios, usually for servers with a great physical distance one from another. Okay, and if we click on synchronous commit, we can select support only manual failover, as it's written down here, or both automatically and manual failover. This configuration is more recommended for production servers where data loss is a concern, because the data will be almost equalized or 100% equalized between the replicas, while in the synchronous mode probably you have a data loss because performance is more optimal, but data is not 100% equalized with both replicas. I'm going to leave in the asynchronous commit mode just so we can see the differences, and later I'm going to change this. But for now, I'm going to leave it like this without any option selected. The endpoints are used to receive connections from all the SQL servers, but they're not going to be changes for this demo. And the backup references is just a matter of preference for where the backups will occur based on which role the current replica has at the moment. I'm going to select any replica, because this is not a concern for the exercise. In the listener, they allow a DBA to configure a name for the client to access the SQL Server instance, no matter on which replica it is currently running. Also, I'm not going to configure this for the exercise, so I'm going to hit next. Here's a standard warning about the endpoints. Yes, I'm going to proceed. Now, data synchronization preference. This is the initial data synchronization preference. I can do it manually by selecting join only or skip it. All I need to do is transfer the backup file to the secondary replica and restore the database there, just as we did with the log shipping. But instead, I'm going to put full, and SQL Server will use the network share to perform backups and log backups and the restores. So it's going to save me a little time. I'm going to hit next. And now the validation takes place. Everything looks good so far, only a warning. Next. Here's a summary on the actions I just selected, and finish. SQL Server now provides me a dashboard on each task that it's going on. As you can see, it's restoring the database on the SAMUS SQL Server and joining to the availability group Avengers. It should only take a couple more seconds before it joins the last database. There it is. Now if I expand the availability group always on tab, let me refresh on Kratos. There it is. Here is the Avengers. You can see it has the role of primary because I am on Kratos SQL Server. Availability databases, here they are, Captain America, Hulk, Iron Man, and Thor. And if I refresh the database status, they are synchronized. If I go to SAMUS, oops, there it is. I'll also be able to see database, but they are synchronizing because I selected the asynchronous commit mode. If I selected synchronous commit mode, they would be synchronized instead of synchronizing. I know it sounds a little bit confusing at first, but it's easy to understand when you get the big picture. If I open the availability groups, you can see the Avengers. It has the secondary role on SAMUS, which is the intended, as we just configured. And here is the cluster I showed earlier. Now you can see the Avengers availability group it is running actually in the node 1. You can notice it's not a whole SQL Server that is allocated to one node or another, only the availability group. This is how it works in the always on, which is different from the standard failover clustering. Let me expand a new query now on the secondary replica SAMUS. I'm going to run a select name and state description from the sys databases. There we go. You can see it mentions all the databases are online that are part of the Avengers structure. But if I try to use one of them, like use Iron Man, it's going to throw me an error saying the database is participating in the availability group but not accessible for queries. Data movement, it's either suspended or the availability replica is not enabled for read access. This is intentional because I did not enable read access, read-only access during the configuration, and it tells me what it needs to be done here. If I go to the primary, right click on the Avengers and properties, I can change this option right here. I can put read intent only or yes for both replicas, but for now I'm going to leave it just like this. Next, I wanted to show you a couple of commands we can enter to pick up information from the availability groups that are also stored in the MSDB system database, such as this one: get replica name, status, and synchronization description. There it is. Both nodes are connected. Synchronization, it's okay. Databases per availability group, per replica, failover type, and synchronization health. There it is. Each database, the replicas. There are some performance counters related to the always-on structure too. We're going to see more about performance counter in the next module, performance. And this, using these performance counters, we can monitor some bytes that have been sent to each replica. Again, it's just a sample on how much level of information we can retrieve using Transact SQL inspecting these tables. There are much others. These are just some samples. Let me close down this and this. Now I'm going to simulate a crash in the primary server, Kratos. And before that, let me close this. Before that, I'm going to recycle the error log on Samus so we can actually see the errors. There it is. After I perform the failover. So going back to Kratos, I'm going to put a shutdown with no wait. SQL Server, it's terminated. If I refresh it here, it's going to throw me some errors. Not responding. Let's wait a couple of seconds. Okay, so my screen got stuck here. I'm going to pause the video and return a few moments later after it has finished the shutdown so you can actually see what's going on with the availability group databases. And here's the error. Okay, that is expected. If I go to Samus and expand the databases or the availability group, refresh, it's in the status resolving. So the databases are not available. You can see by this red icon besides them. If I try to read the error log to understand what happened, let's take a look. There's my error log. If I scroll down a little bit, there it is. Let me switch to text mode. It's easier to grab the messages. Okay, there it is. The local replica of availability group Avengers is going offline because the corresponding resource in the Windows Server clustering is no longer online. That is the SQL Server Kratos. This is an informational message, and here the state of the local availability replica changed from secondary normal to resolving normal. So the databases are not going to be started. The whole availability group is not going to be started until I manually failover stating that I allow the data loss to happen. If I do this, again, select the status of the system databases, they are still showing online, but when I try to open them, I'm going to receive the very same error. Let's use store, go. Same scenario. What I'm going to do now is force the failover of the Avengers availability group, allowing the data loss to happen. And before that, let me recycle the error log again so you can see the errors without floating the screen from messages. There we go. I'm running this command on the SQL Server that I want the availability group Avenger to move to. In this case, I want them to move to SAMUS. There it is, execute, and completed without any errors. If I refresh the screen, let me collapse this, refresh, availability group, there it is. Now the Avengers is showing as primary on the SAMUS SQL Server. So my secondary replica assumed the availability group Avengers with the role of primary. If I try to read the error log now, I'm going to see what's going on. Again, to text mode. There it is. The database is changed from resolving to primary because it was pending the manual failover confirmation due to a role synchronization. As it's written here. Primary pending to primary normal. I go back to my cluster interface, hit node 2. There it is, the Avengers. Just like that. Now I'm going to show you the difference with using synchronous commit with automatic failover. First, let me open Kratos and I'm going to drop the Avengers availability group. Okay. Drop availability group Avengers. There we go. I'm going to remove the databases from the secondary. They remain in a restoring state. Otherwise, I'm going to have errors when recreating this structure. There we go. Last one. Alright. Moving back to Kratos. Using the same procedure as before. Avengers. The 4 databases. Adding the replica, SAMUS. And now I'm going to select synchronous commit for both with automatically failover. There it is. And no changes to the other options, just that one. As soon as it completes, I'm going to shut down the primary replica Kratos so we can see what happens with the secondary right away. And we can see the difference between the asynchronous commit mode. Should only take a couple more seconds for Thor database to join the availability group here. Last item. Just a couple more seconds. There we go. Close it. Expanding again. Primary Avengers on Kratos. That's okay. And if I refresh here, everything is synchronized. It's the expected way. And secondary on SAMUS. Let me close this out. Closing this too. And now I'm going to shut down Kratos immediately. See what happens next. If I refresh this, it's already a primary. As you can see, there is no need for DBA intervention after the primary replica suffered a crash. For production environments, this is the more safe options where you can configure your availability groups unless data loss is not a concern. You were able to see how quickly it was comparing to the other method using asynchronous commit. If we use the error log now on the secondary, you can see that it takes only a couple of seconds before the databases are brought back online. Let me switch to text mode again. There we go. See, right here, connection terminated with primary, changing to resolving, and then primary normal. If I expand the dashboard, it's going to give me a good status for Samus, and of course the other one is down, so possible data loss alert. Module 8, Performance Basics. The problems involving performance aspects of any database system usually are the most complex ones to troubleshoot, and with SQL Server this is not an exception. When a client complains that a database server is slow, the application queries are running slow or slower than normal. Even if it's a few seconds more, it can make a big difference at the end. Consider yourself withdrawing cash from an ATM. After you selected the amount of cash you want and you enter your password, it takes up to 5 seconds max to the money to be dispensed. If it took 5 seconds more, you already start to feel the delay. With the business application, there is no difference. These three statements are common complaints from end users when having SQL Server slowness problem, and it's the DBA duty to attempt to narrow down the cause of it. These are some questions the DBA can use to evaluate a performance situation before touching the system itself by running scripts and collecting data. It is very important to have one representative from the business application or the client when troubleshooting performance. The first one, if there are recent changes to the physical infrastructure or the application code or application software. The accepted versus current response time. The client must be able to measure how much the application is slowed down in numbers. Consider periods such as month ends, financial closing, and ask if there are changes to the data volume that is being processed. Ask if the situation can be reproduced. Maybe if the client is having performance problems with a store procedure that only displays data, if it can be reproduced at any time, it's a very good way to start, so we can monitor the environment in real time while the problem is happening. Check if there's any performance baseline available. By having metrics on performance counters such as memory or CPU utilization, it gets easier to compare data from before and after the problem started. If there is no baseline available, then it's a good moment to start one. And finally, a classic but not to be missed question, how many users are affected? This might look simple, but it's a question that can save you a lot of time since you isolate the performance condition to a specific group of users. And here is where to start. If you are new to SQL Server or have no experience with performance troubleshooting, these steps offer a general health check guideline on where to look when tackling the outage situation. This, of course, considering that you are not given any more specific information from the client on where the problem might be. First things first, look for any hardware-specific errors on Windows Event Viewer logs. Also in the Event Viewer, look for operating system level errors such as memory pressure or high CPU. If nothing was found, proceed with checking the SQL Server itself by inspecting the configurations and reading the SQL Server error log. Going one level deeper, the problem might be specific to logical design, such as being on table data types, missing indexes, or indexes fragmentation. And finally, a more advanced aspect, the query plan itself. Should the problem be with any specific query that is not getting completed or completing with delays, the query plan will inform where is the highest cost of resources. The Performance Monitor is a built-in tool from Windows Server that allows you to build a performance baseline by collecting data from many aspects such as memory or CPU utilization. You can get periodic data by starting a data collector set or use it on demand simply by selecting the counter list you require and view it in real time using graphical or numeric display. Some counters are specific to SQL Server data, can access directly using TransactSQL. They are on this DMV sys DMOS performance counter. And these are some of the common counters used for baselining performance data. There are hundreds of them, and their use vary according to what you're looking to measure. These are used to measure disk read and write latency. Depending on the values, you can identify which disk has the bottleneck. Physical memory, CPU utilization, access method to measure table scans and index search data, SQL Server Buffer Manager to monitor how much time the data pages are being kept in memory, Memory Manager to get the total usage of the buffer pool and max server memory settings, Statistics to verify the volume of workload of the active queries. The Task Manager and SQL Server Activity Monitor are reactive tools because they do not present cumulative data. They can be used to get a quick view of the current state of a SQL Server in regards of a CPU or memory usage, and be used as a temporary evidence. The SQL Server Profiler has a more specific use. It is recommended when you want to capture specific data from a SQL Server in real time to monitor a temporary condition, such as store procedure performance, audit logins, or even track down specific application errors. The drawback of using Profiler is that you need to be certain on which data you want to capture and apply the right filters. Otherwise, you'll have a massive amount of data, and as it grows, the harder it will be to narrow down the search. A Profiler report can grow quickly and take massive chunks of disk space if not used with caution. It has been marketed as a deprecated feature and will be removed in future versions of SQL Server. The extended events introduced in SQL Server 2012 has the same functions and are considered a light version than Profiler. When someone asks what is the best way to get performance data from SQL Server, there is not a single or right answer. It really depends on your preference, the tools you have available, and the objective of the data capture. Here are some alternatives to enhance this process by combining it with performance monitor data. The SP Who's Active is an enhanced version of the original SP Who that can be downloaded for free. It provides a lot of details and formatting that are very useful for performance troubleshooting. You can set up your own SQL Server agent jobs to capture data and save them on a table or tables from a database of your preference. You can use the DMVs to monitor real data in case you just need to take a quick look at the current performance counters without needing to save information. The weight statistics is a very powerful resource of performance data, but is more complex and requires understanding of some internal structures such as latches and threads execution model. And there are others if you look on the major sites, each one with a different purpose. So all you need to do is a little research to find the one that suits your needs. We have arrived in the end of the training, and here is a review on what was covered on each module. In the introduction, I have briefed you with the course scope and what you expect from each chapter or module. On the architecture, we studied the internal aspects of a query lifecycle, viewed some key internal components, asset properties, and more. In security, we learned the importance of the service account, the aspects around the Sysadmin privilege and risks associated to it. Also, created and changed permissions from a user and changed audit level settings. In the health check part, we studied the availability checks, the difference between using the graphical interface and transact SQL, DBCC commands, and dynamic management views. Also, we viewed through a demo a blocked process and a deadlock happening inside a SQL Server. The system databases and databases data and log files were covered in Module 4. Also, we studied the autogrowth settings, transaction log internal structure, and shrink file commands. And on this demo, we saw the errors happening live, just as the file group full and the error 9002. On Module 5, we covered backup and restore concepts from the full backup to the tail of the log one. It was reviewed also which one was applicable for each scenario as well as the restore. On SQL Agent module, it was shown the creation and configuration of a job manually, browsing a job history, and the difference of using the maintenance plan. In the high availability, there were the definition of a recovery point objective versus recovery time objective and a presentation of each solution available. Also in the demo, we were able to view the log shipping and always-on configuration and some common problems related to them. Finally, in the last module, performance, some general guidelines on performance troubleshooting, the tools and methodology available to build a baseline of performance data. Now that we have reached the end of the training, I would like to emphasize this was just the tip of the iceberg. There is so much more to say, study, and learn about SQL Server, but I hope I could give you a brief idea about the major aspects surrounding the database administrator job. I have had a great time and fun with creating and producing this training, and I hope you enjoy the final result as well. Should you have any question, feedback, or critic, feel free to contact me at any time using the external email address in the next screen, or contact me directly if you work at IBM. Again, thank you for watching.